So we're going live. So let me get rid of this YouTube video. And then we should be going live in just a few moments. Okay, it's here. All right. So if you want to check that out online, you can go over to this link that I'm providing to everybody. So we're going to be streaming on all sorts of platforms such as YouTube and Twitch. So if you know those websites, you can always go over there and check those out. But otherwise, we're going to be starting today's class. So this is HackerFrogs After School, and we are doing web app hacking starting today. So let's get into it. So this is HackerFrogs After School Web App Hacking. This is the intro. So before we do the first session, we're going to be doing this intro over here. And welcome to HackerFrogs After School. HackerFrogs After School is a cybersecurity program for learning beginner cybersecurity skill across a wide variety of subjects. This session is about Intro to Web App Hacking. So what is web app hacking? Web app hacking is the intentional abuse of systems and applications accessed via the internet by a user, which benefits that user in some way. This benefit can take the form of access to unauthorized data or systems, the deletion of data, denial of website services, or any number of other benefits to the person who is doing the hacking. In order to learn web app hacking, we must learn about the internet, how websites work, and a good amount about the technologies and software found in that space. Most students know at least the basics of using a web browser and how to use websites, so we will build on those skills to establish a collection of techniques to explore and hack web applications found on the internet. It is important to note that at no time during our study of web app hacking will we engage in testing or hacking of websites or internet spaces that A. We do not own, or B. Are not intentionally set up as learning environments for learning web app hacking education. So what we're trying to say here is that we will not do bad person hacking, we will do good person hacking, and we're learning about hacking to be good people, is what I'm trying to say. So we're also going to be talking about CTFs because we love CTFs over at HackerFrogs, and HackerFrogs After School classes prefer to incorporate CTF games into classes for a more interactive experience. But what are CTFs? Cybersecurity Capture the Flag, CTF games, are training exercises where the goal of the exercise is to capture the flag through the use of cybersecurity skills. In this context, capture means to gain access to a file or other resource, and flag refers to a secret phrase or password. So the CTF game that we will be playing to learn basic web app hacking skills is called Natas, which is hosted on the Over-the-Wire CTF network. The Over-the-Wire network hosts several different CTF games. The Natas CTF game is made up of many levels of increasing difficulty. The initial levels from 0 to 10 are going to cover the target web app hacking techniques for this course. So what's next? In the next workshop, that is this workshop, we're going to begin our journey into web exploitation with the Natas CTF game. So everybody, let's start. All right, so this is the first part of this web app hacking course. There are going to be 8 sessions in total for web app hacking, and by the end you're going to know a number of different techniques that you can use to hack against web applications. So this is the first workshop for our Intro to Web App Hacking course. Before we start, let's introduce the learning materials we'll be working through in the course. So the Natas CTF. The CTF game we'll be playing to learn basic web app hacking skills is called Natas, which is hosted on the Over-the-Wire CTF network. The Over-the-Wire network hosts several different CTF games, and the Natas CTF game is made up of many levels of increasing difficulty. The initial levels from 0 to 3 are going to cover the target web app hacking techniques for this session. All right, so to learn more about the Natas CTF rules, let's navigate to the following URL. So this is overthewire.org, wargames Natas. Particle to Do on Twitch says hello. Hello, Particle to Do. We're doing the first lesson in web app hacking today, so it's probably stuff that you already know, but you're welcome to stay if you like. So let's take a look. Okay, so Natus over the wire. Let's get that web page. Natus over the wire. Leave the page. Okay. So everybody, I want you to take a look at this web page. Oh, that's an ugly looking link. Let's get the better looking link. This is the better looking link. Okay, just over here. All right, so this is overthewire.org. It's a CTF platform, and there are several different CTF games here. The one we're going to be playing to learn web app hacking skills is called Natus. And here it says, Natus teaches the basics of server-side web security. Each level of Natus consists of its own website located at http://natus.labs.overthewire.org, where X is the level number. There is no SSH login. To access a level, enter the username for that level and its password. Each level has access to the password for the next level. Your job is to somehow obtain the next password and level up. All passwords are stored in the /etc/natus_webpass directory. For example, the password for Natus level 5 is stored in the file /etc/natus_webpass/natus5 and is readable by Natus4, the user Natus4, and the user Natus5. So we're going to start at the following URL over here. Particle to Do says the basics are always good to review. That is correct, and thank you very much for that insight. Okay, so we have a username and a password that we're going to use. So the username and the password are both the same. It's going to be natus0, and we have a URL over here that we're going to navigate to. So everybody, let me copy the link and provide it to everybody. And please navigate to that website yourself in your web browser. Okay, so let's navigate to the website. Okay, so when you come upon the website, there's gonna be this pop-up window over here, and it's gonna ask you to log in. It's asking for a username and a password. So what this is an example of is a very early type of login form on the internet. So we'll learn a little bit later about different ways we can log in to websites, but this is the most basic way. So under username, we just need to provide the name natus0, and in the password field, the password is going to be the same as the username. It's natus0. After that, click on Sign In, and you should be signed into the website. Okay, so everybody, if you manage to get to this page, and you can see this text over here, please type in the chat, I'm on Natus0, smiley face. Okay, that's great to see, great to see. We've got some people on Natus0. And so on this web page here, it says you can find the password for the next level on this page. So does anybody have any clue as to what we could do to see some extra information from this website? If you know how to get extra information from the website, please let us know in the chat. Otherwise, we'll be talking about it in just a few moments. So we're using, okay, so user D says that we can inspect. That is one way we can get extra information from the website. But I think we can do something that's a little more basic, a little more simple than that. And that is to simply look at the web page source. So inside of each one of these, so this is a web browser, and the web browser shows you what's on the web page, but this is not what is sent. So this visual representation is not what is being sent by the web server. And the web server is basically the computer that gives you the web page. what we actually receive is something that looks more like the HTTP source. And you can see the HTTP source by doing right-click and then select from the options. There should be one option called View Page Source. So if you can right-click and select the option that says View Page Source, it might say something different, but I think it will say something like View Page Source or View HTTP Source. I want you to select that option, and then you should be able to see the HTTP source code over here. So if you're able to somehow see the source code, please let us know by typing in the chat, I see the source. Smiley face. Okay, Particle Doodoo says the shortcut is Control U. So there is a keyboard shortcut you can do to see the source code, which is Control U, but that'll come in handy a little bit later. All right, so this is what is actually sent to your web browser, and the web browser interprets this code over here, and it turns it into a website that looks kind of like this. So can anybody identify what's going on? Well, maybe it might be a bit much to ask if you can identify what's going on in here. But on YouTube, Marco Pulisic says Dirbuster. We don't need a tool like Dirbuster for this challenge, but there is a password. So this is known as an HTTP comment, and these are comments that are left in the code to let other developers understand what the code is doing. And for example, there's this comment over here, and it says this stuff in the header has nothing to do with the level. So we can ignore the stuff in this portion of the HTTP source, and you see that the actual content of the web page is this over here. You can find the password for the next level on this page. And there's another comment over here that says the password for Natus1 is this password over here. So if something is put inside an HTTP comment, that means that the web browser isn't going to render it, and it's just going to be ignored by the web browser. But it's here, and developers can see it. So what we can do is we can just copy this. So this isn't like a flag for the picoctf. This is actually the password for the next level. So what we can do is we can just copy this, and then we can log into the next level. And how do we do that? We can go back to the Natus0 page, and then we can go to the address bar, and in the address bar we can edit the address. So instead of Natus0, it now says Natus1. So go ahead and edit the address so it says Natus1, and then hit enter in your web browser. So this is going to bring us to the next Natus level. It's going to ask for a username and a password. So the username is always going to be the level. So this is Natus1, so the username is Natus1. And the password is going to be the password you just copied. So you just need to paste it in and click on sign in. Okay, so everybody, if you are able to see this text over here and you're on Natus level 1, please let us know by typing in the chat, Natus1 in, smiley face. Okay. All right, so let's. I've got a little presentation talking about what we did in the previous level, but I forgot to show it. So this is about HTTP source code. That was Natus level 0. Web browsers render out web pages based on the HTTP code that is provided by the web server. Every web browser allows us to see a web page's HTTP source code. So for web app testing, this allows us to find interesting directories, developer comments, and more. So sometimes inside this source code, we can see all sorts of interesting file locations and directories, but we'll talk a little bit more about that later. Okay, so now we're on NATAS level 1, and what we need to do is we need to do some lateral problem solving. So it is said that when hackers encounter a locked door, they look for an open window. We can look at web app security in terms of checking which doors and windows are locked and which can be opened. So if we take a look over at the NATAS 1 webpage over here, it says you can find the password for the next level on this page, but right-clicking has been blocked. So if you try to do some right-clicking on this page, it'll tell you that right-clicking has been blocked. So we can't use the right-click method to get access to the source code. So does anybody know another method we can use to access the HTTP source? If you know, let us know in the chat. And I think Particle to Do in YouTube chat, in Twitch chat, sorry, has told us about one method already. If you know, let us know. So if we go over to our favorite search site, google.com. So let's see, user PK, it says that they need link. So we will give you the link. So we are at this. We're at this page over here. Let me get the password for you. You'll need a password and a username. Let me grab the username and password and I'll provide it to you so you can join in. Okay. Oh, that doesn't work. You know what you should do? You should go over to this link and copy the NATAS1 username and password from here. Unfortunately, in the Zoom call, you can't copy text. So, all right. So, what we were doing. So in Google, we can actually look this up. So, depending on what web browser you're using. So, for example, I'm using Firefox right now. In Firefox, how do we view HTTP source code? Okay, so it says context, click in the page and select view page source. Press Control U on Windows and Linux or Command U on Mac OS. So this is how we can access the source code in another way. So we can't use this method over here, but we can do the Control U keyboard shortcut. So if you're able to access so we can use either Control U on our keyboard, and that's going to give us this source code over here. But another way we can access it is by editing our URL over here. So if we can put this in front of the address, view-source, and then we can see the source code. So this works for any page. So if you go over to Google over here, and in Google we put view-source and then and then hit enter, then that's going to give us the source code. So the source code for this page is way more complicated than the source code for the NATAS1 level, but this is how we can do it. We can do view-source, in front of the address, or we can use the Control U keyboard shortcut. And we see here that we have the same password, the same location for the password. So the password is inside of an HTTP comment. So user D asks, what's the command again? So we can do Control plus U. So it's Control plus U if you're on Windows or Linux. If you're on Mac, it's Command U, I think. All right, so we've got the password for NATAS2. We can just highlight it and copy it. And then we're going to exit out of here Oh, that's really messy to look at. And what we can do is we can go over to the Natus1 page and we can edit it so that it is instead the Natus2 page. So once we've edited this so that it says Natus2, we can hit enter to navigate, and then we can log into Natus level 2. The username is Natus2, and the password we're going to paste in, and then click on sign in. Okay, so everybody, on Natus level 2, it says there is nothing on this page. If you can see this text, because you've logged into Natus level 2, please let us know by typing in Natus 2 is too good, okay, and then smiley face, just to let us know that you're here. Natus 2. All right. If you're having problems, please let us know in the chat, and we'll try to solve your problems. Okay. Well, not every problem, just problems that have to do with navigating to this page. But in the meantime, let's. The command doesn't work, says user D. So okay, what I want you to do, user D, what web browser are you using, if I may ask? Are you using Firefox or Chrome or something else? You can also try doing the view-source and then colon. Just put view-source colon in front of the address, and then hit enter, and you should be able to see the source code. So I might so I'll also ask user D, is there another web browser you can use? If you have another web browser on your computer, yeah, so you have the Brave browser. Go ahead and try accessing Natus level 2 or Natus level 1 on the Brave browser and see if you can see the source code on that. Okay, so let's see. Let me finish off the concepts from Natus level 1 first before we do Natus level 2. Okay, so we're talking about lateral problem solving. Here I can ask something like ChatGPT. What are some different ways we can see HTTP source code in the web browser if mouse right-clicking is not possible? So this is where a security tester's most powerful weapon, research, comes into play. So it sounds kind of corny, but the most powerful tool that hackers have is the ability to do research, and through research we can figure out how to hack stuff. So two common research tools used these days are ChatGPT and the Google search engine. Don't feel bad about going over to ChatGPT and asking it a question, because I ask dozens of questions to ChatGPT every day about different technologies, and it doesn't always get me the correct answer, but ChatGPT doesn't judge you for asking dumb questions. If you ask, other people about questions, they might think that, oh, that's such a simple thing. Why don't you know that? But ChatGPT doesn't judge you. If we go over to here, we can use ChatGPT and Google to find our answers. So once the obstacle to a problem is discovered, we can research a way to overcome the obstacle or a method of bypassing it. So ChatGPT in this case tells us that we can do our keyboard shortcuts, Control U to view the page source. On Mac, it's Command plus Option plus U. Is it Command plus Option plus U on Mac? If anybody's using Mac, please let us know if it's actually Command and Option and U. Okay? Okay, so user D, did you manage to solve your problem? Because we definitely want you to keep up with the rest of the class. All right, great. That's good to hear. Okay, so we're on Natus level 2, and let's go back. So in Natus level 2, it says there is nothing on this page. So as usual, you can access the page source. So in Twitch chat, JugPearl says, yes, Command Option U works on Mac. Okay, good to hear. I actually have very little experience working with Macs. So if other people who have Macs and have experience using Macs can tell us about Mac stuff, that would be very much appreciated. Okay, so you can use the Control U keyboard shortcut or Command Option U if you're on Mac to see the source code. So once again, in the comment over here, it says this stuff in the header has nothing to do with the level. So this is the header section. This is the beginning of the header section on line 2. And it stops on line 10. So everything from 2 to 10, we can ignore this when we're solving the level. We only need to worry about this section over here. So can anybody identify something interesting inside of these lines from lines 11 to 17? So there's something important that we should pay attention to between lines 11 and 17. What is it? Okay, user BD says there's a link. And user JugPearl says there's a source file. Yep, that is correct. So on line 15, there is a source file. So it's basically every time you put an image on a web page, you have to provide a link that links to the image, and it uses this source keyword right here. So it says files/pixel.png. So pixel.png is the file, and files is a directory. So we can actually access this link by clicking on it. We can click on it, or we can just right-click on it and put it in a new tab. Oh, we can't put it in a new tab. All right, we can click on it. And we see here that this is an image that is just a single pixel. So we can zoom in real close, but we still see that it's just a single pixel on the screen. So what's important about this? So there's something very important about there's something very important about this discovery, and it's not the file itself. So this pixel.png file, it doesn't matter for this challenge. But what is important for this challenge that we just discovered? Can anybody have a guess? Okay, user D says you can't view page source. User BD says it's a dot, right, no problem. Okay, so I think we might, if we view the page source, well, okay, we can't view the page source. This is the page source. If we go out of page source, we can see that it's the same thing. But there's something that we discovered. We discovered this. So there's this file over here, pixel.png. But what's before pixel.png? On Twitch, user JugPearl says, we are able to open files. We have the access file path. Right. So we have the file path. So we discovered that this pixel.png file is inside a directory called files. So we didn't know this before. So what we can do is we can directly access the files directory. Does anybody know how we access the files directory? So user D says we use the cat command. Well, we could use the cat command if we are on Linux, but we're not on Linux right now. We're on the web browser. So no problem. But this is how we do it. So to access the files directory, all we need to do is go to go to the web address, and after the slash, so it's going to be natus2.natus.labs.overthewire.org, and then there's going to be a slash, and then we can put in the name of the directory we want to access, which is files. So it's going to be overthewire.org/files/. So all you need to do is type that into the web browser and hit enter. And this is going to let us see the contents of the /files directory. So there's the pixel.png file in here, as well as this file called users.txt. So before we access the users.txt file, let's talk about what kind of vulnerability this is. So we're talking about directory indexing, sometimes called directory listing. And what directory indexing is, it's an insecure setting on websites that allows users to see the file contents of web directories. Although it's quite rare to encounter this issue on modern websites, it's still very common to find it on older websites. So if you come across websites that are very old and people haven't been doing a lot of updating on them, then you're going to be able to see this kind of directory indexing vulnerability on them. It basically means that if somebody directly navigates to this directory, you can see everything in there. So in this example here, you've got your admin.html file, you've got your passwords.txt file, you've got your user database file. So these are all made up, but it just tells you that if they've got sensitive files inside a directory, you definitely don't want everybody to be able to see them. So if directory indexing is enabled and a malicious user is able to discover different directory paths on the website, either through guessing or HTML source analysis or a process called directory busting, then sensitive files may be discovered, stolen, or otherwise abused. Okay, so let's go back. So on this page here, no, we're going to this link. So this link here, and I'll just provide it to everybody in chat just in case you need to get the direct link. So this directory here has the pixel.png file as well as this users.txt file. So if we didn't know about this users.txt file, it wasn't in the HTTP source for the last web page, but we can just click on it to access it. And we see here that there's a bunch of usernames and passwords. So it's going to be the username and then colon and then the password. This is a pretty common format for doing username passwords. So we see there's Alice, there's Bob, there's Charlie, there's Eve, there's Mallory, but there's also the Natus3 password over here. So the Natus3 password is this. So all we need to do is copy the password, and then we can log into the next level, which is Natus level 3. So we're just going to get out of here. And then on the main Natus page, we're going to edit the URL so that it says Natus 3 instead of Natus 2, and then hit enter. User BD says it's like a rabbit hole. So if you do testing on websites, you can often feel like you're running around like a rat in a maze. But if you know what you're looking for, then it becomes a lot easier to navigate and do security testing on these websites. So Natus 3, the username is going to be Natus 3, and the password is going to be the password we just got. Paste it in and click on sign in. Okay, so it says there is nothing on this page. So there's probably something on this page. We should probably look at the HTTP source. So user JugPearl on Twitch says, using web vulnerability scanners, would it find these vulnerabilities? Yeah. So any web vulnerability scanner tool that you use is probably going to tell you about directory listing. It'll tell you if it finds a directory, it'll tell you if it's listable or not. And there are some other like very simple web app security tests that web vulnerability scanners will tell you as well. So okay, so this is Natus level 3. It says there's nothing on this page. If we look at the page source, then we see something in these comments over here. So we can safely ignore all this stuff. This is actually the password that we just inputted, so we can safely ignore this stuff. We're on Natus level 3. We're trying to get to Natus level 4. It says no more information leaks. Not even Google will find it this time. So if we didn't know what this is talking about, does anybody know how we could find out about this kind of comment? If we want to research this comment, what tools can we use to research this? Jugpearl says ChatGPT. Okay, and let's see. User BD says another search engine. Yeah, so this is a little bit obscure, but if we try to look for this in a search engine, it might not find anything. But if we ask something like ChatGPT, I saw this comment in an HTTP source code. What could it mean? And then we paste in the comment and hit enter. So it's going to think a little bit. Okay, so this comment likely hints at the removal or hiding of previously exposed information. In CTF challenges, it could suggest that there's hidden or obscured data, server-side filtering, unlisted files or directories. So this is the second point over here is what we're looking for. This challenge could involve finding hidden files, directories, or endpoints that aren't linked properly, that aren't linked openly. Look for files or paths that might have been de-indexed by using robots.txt or placing files in directories that are unlisted. So this is what we're going to be talking about in this challenge. So in this challenge, they're actually talking about this file right here called robots.txt. So let's learn a little bit more about this file. Okay, so first we're going to talk about HTTP requests. So when we're learning about web app hacking stuff, we have to understand how how the internet works and how web browsers do requests and how they send requests, how they receive requests, stuff like that. So HTTP is the backbone of the internet, and all web browsers receive web page content by sending HTTP requests to web servers. So your web browser is going to send all of these HTTP requests to the website, and then it's going to receive a response from the website, and that's how you're going to get your web page content. So in return, the web servers send the web browser an HTTP response, which is rendered by the browser and presented by the user. So each time you load up a web page, you're sending an HTTP request, and then whatever you receive in response is going to be made pretty by the web browser, and that's going to be the web page that you see on your web browser. So each HTTP request is made with a specific HTTP method, which tells the web server what kind of interaction you want from it. So, for example, when you're getting information from the web server, you're usually using this method right here, which is called GET. So this is an example of the kind of information you would send in a GET request. So you send a GET request via HTTP to the Natus CTF server, and then it's going to send you a response, which is basically the web page that you're requesting to get. The most common HTTP method is the GET method, which retrieves the contents of web pages. So the web server will always return an HTTP status code with its response in the form of a 3-digit number. Any code in the 2XX range is considered a successful response. So we can actually take a look at what the raw response and request looks like. And so if you have a Windows computer, you can go over to your search bar in your Windows computer and then type in the letter CMD. So So when you do that, you should see something that looks like command prompt. What I want you to do is I want you to click on that icon over there under command prompt, and it's going to open up a window like this. So this is a Windows command prompt. It's kind of similar to a Linux command prompt, but it's not exactly the same. But let me see if I can make this bigger. Let's see, properties. I can increase the font size to 36. Okay, now it's nice and big. Okay, so you don't need to do this yourself, but I'm going to show you an example of what happens when we, let's see. So there's a program called curl, and we're going to be using it a little bit later during our web app hacking sessions. But we can use the curl program to retrieve web pages. So let's see, curl, and let me get something very simple like example.com. So, okay. So example.com is just an example website that's up on the internet. And we see a bunch of different stuff that's sent when we send our request. So we send with our request a bunch of different information over here. So we're going to get the page with the HTTP 1.1 protocol. We're going to send it to example.com. We're using curl, and then we receive a response. So in the response it says 200 OK, and then it tells us how many bytes we're receiving and all sorts of other information. And this is the code for the web page. But we got off topic a little bit. What we really want to talk about is robots.txt. So this is what the CTF challenge is talking about. So what is this robots.txt file? So search engines such as Google, Yahoo, DuckDuckGo, etc., they use programs called robots to visit websites and map out the web pages there. However, this may cause sensitive areas of websites to appear in search results. So if you have a super secret project on your web page, on your website, and you don't want Google to get the information about that, then you can use this robots.txt file to prevent the search engine robots from looking at that page. In order to prevent this, website administrators can add a file called robots.txt to their website, which specifies which directories and or pages of the website are off limits to search engine robot programs. So there's actually a robots.txt file on the Google website. So if we go to google.com, google.com/robots.txt. So just type in google.com/robots.txt. And then this is the Google website's robots.txt file. This is what it allows and disallows the search engine robots from recording. So it also has this user agent section right here. User agent just means the program that's being used to access the web page. So user agent could be something like the Chrome browser or the Firefox browser or the curl program. But it also says we're going to allow you to look at these things. We're going to disallow you to look at these things. So can you tell me what the problem could be with using the robots.txt file to tell the robots which super secret pages we shouldn't be looking at? So if we've got super secret pages we don't want the search engine robots to look at, what's the problem with listing them out on the robots.txt file? So user Marco Polisic on YouTube says we would be able to see the hidden path. That is correct. So because, unfortunately, if malicious users know how to find the robots.txt file, then the contents of the file could potentially lead them to sensitive areas of the website. So you don't necessarily want to put all of your secret stuff in the robots.txt file. Okay, so let's solve the challenge. So in the challenge it says, not even Google will find it this time, it's talking about robots.txt. How do we access the robots.txt file from the Natus 3 webpage? Can anybody tell us how we access the robots.txt file? Okay, so just like accessing the robots.txt file on the Google website, we can just go up to the URL bar, and we can put a slash and then robots.txt. So remember, it's whatever website we're on, so overthewire.org, and then slash and then robots.txt. So if we access it, we see here that user agent is any user agent. Anything can record the website, but it's going to disallow access to this directory. So the directory is /secret, but with 3's instead of e's, and then slash. So all we need to do to access this hidden directory is copy the hidden directory, and then go up to the top where the address bar is, and then highlight /robots.txt and paste in the secret directory over here. So if you just want to access this directly, I'll provide the URL in the chat. And then hit enter. Okay, and this is too big. Let's make it smaller. So this is also directory listing and directory indexing. Let's see. User BD says the pixel got bigger. Yeah. So so in case you didn't know, you can actually make the text inside of your web browser bigger and smaller. So you can do Control-Shift+ to make the text bigger, and you can do Control- to make the text smaller. So this comes in handy if there's some really small text or really big text on the page. So in this secret directory, we also have a users.txt file. So we can access that to finish the challenge. So just click on it, and then it says natis4 : this thing over here. So this is what we use to access natis level 4. Highlight it, copy it, and then back at the base natis 3 page, we can edit this so it says natis 4 instead of natis 3. The username is going to be natis 4, and the password is going to be the password we just got. So just paste that in and hit sign in. Okay, so everybody, if you can see this text over here, access disallowed, please type in the chat, those clanky robots.txt, smiley face. As usual, if you're having problems, let us know what problems you're having in the chat, and we'll try to solve your problem. Okay, so that took a little longer than I thought it would, but I think we have time to solve one challenge over at PicoCTF before we finish today's class. So over at PicoCTF, I'd like you to log into the website, and if you don't have the link, let me grab the link for you. All right, so we've got users D and users BD say those clanky robots. They sure are clanky. Okay, so once there, so we actually don't need a web shell, so we don't need to worry about that step. We're going to be solving, let's see, this challenge over here, which is called Where Are the Robots? Okay, so just to practice accessing the robots.txt file, we're going to use this challenge right here. So this challenge is Where Are the Robots in PicoCTF? And I think there's a direct link. So even if you don't have a PicoCTF account, you might be able to follow along. Okay, so where are the robots? Okay, we've got a link. So everybody, I want you to navigate to this link And if you're able to finish the challenge before I help you finish the challenge, then you are a cool person. But let's access the challenge, okay? Okay, so it says, welcome, where are the robots? All right, so does anybody remember how to access the robots.txt file? So if you take a look at the source for this page, there's not very much here, but it says, where are the robots? So we can just go up to the top, and in the URL, we just need to add robots.txt after the slash over here. So it's 60915 slash, and then it's robots.txt. And we see that it disallows this directory right here. Oh, this is not a directory, this is a file. So this is this 8028f.html. So we can just copy this. Then go over, okay, so JugPearl has finished the challenge ahead of time. Thank you very much. You were an awesome person, JugPearl. You can find the robots. Okay, so just highlight /robots.txt, paste in this over here, /8028f.html, and let me grab that URL just in case you wanted to access it directly. Okay, hit enter, and then it says, JugPearl says, I'm awesome because of you. I'm sure you you had all sorts of knowledge before you started learning from these classes. Thank you very much. Guess you found the robots. Okay, so picoctf calculating machines. Just highlight the flag, go back to picoctf, paste in the flag, click on submit flag. And it looks like it's not responding. So I'm going to have to wait for about 10 seconds. And then try again. Okay, so click again. It's going to give me another error. Let's try one more time. Okay, hooray, we solved the challenge. All right, so everybody, if you managed to solve the challenge, please type in the chat, I found the robots.txt again. Smiley face. Okay, so that's about going to wrap up today's lesson. Before we finish out, let's take a look at let's do a quick summary and take a look at what we learned in today's lesson. GrayFox01 on Twitch asks, is picoctf free? Yeah, picoctf is completely free. There's you couldn't pay for it if you wanted to. So if you want to sign up for it, you can go over, let me grab the link. So picoctf register. So you can go ahead and go to this link. Oh, that's a bad looking link. Let's get the prettier looking link. This link is nice and pretty. Okay, so this is the link you would use if you wanted to sign up for picoctf. Okay, so what did we learn in today's web hacking workshop? So we learned about lateral problem solving. The most important skill to develop in cybersecurity is researching. Google and ChatGPT are two powerful research tools. Use them wisely. Don't feel bad about using them to solve problems because you have to use all of your tools at your disposal. We learned about directory indexing. Directory indexing, sometimes called directory listing, is a vulnerability on websites that allows users to see the file contents of web directories, which can lead to sensitive data exposed to arbitrary website visitors. And we learned about robots.txt. It's a special file included on certain websites that indicate which files on the site can and cannot be indexed by search engines. It can be abused to point malicious users to sensitive parts of the website. All right, so what's next? In the next HackerFrogs After School Web App Hacking Workshop, we're going to continue learning web app hacking with the NetSCTF. And in the next workshop, we're going to be learning about, let's see, what are we learning in the next workshop? Let me look that up really quick. Sometimes I forget. So in the next workshop, we're going to be learning about HTTP headers. So HTTP headers as well as HTTP cookies these are the topics we're going to be learning about in the next workshop. So I'm going to finish out the Zoom call with the students who are learning via Zoom. But for everybody else, you're going to see a be right back screen. But first of all, let me put on a little video of my backyard birds that you can watch while you're waiting for me to come back. So these are the backyard birds. I'm going to finish out the call with the Zoom students. I'll be back in a few minutes, okay? Okay, everybody, we're back. All right, so just in time to see the bird with the broken leg come to get some more peanuts. All right, so everybody, we have about an hour or so before the next class starts. So between now and then, we're going to be doing a little bit of a demonstration. And we're going to be doing a hacking demonstration on the, let me close out that file, on the VulNyx website over here. So the VulNyx website is a website where you can access downloadable virtual machines to hack against. So we're going through all the easy machines over here, and we're doing some hacking walkthroughs on them. So if you don't want to be spoiled, if you don't want to be spoiled for these challenges, you don't have to watch. But let's see. Jugpearl says, downloadable VMs. Do I need to do VMware install? Yes. So you can use either VMware or VirtualBox. You just need to download the virtual machines that are associated with the challenges and then deploy them to your VM network. So just put them on the same network as your attacking machine, something like Kali Linux or whatever other attacking machine you want to use for security testing, and then you would hack against them that way. So before we start, let me set up my environment. So for these CTF challenges, I like to create a few different terminal tabs so I can rotate between them when I'm doing different activities. Okay, so we've got a few different ones here. Let's make this one a little smaller to match everything else. And let me grab, I've got a little PDF file that I'm going to be demonstrating for some of the vulnerabilities on this box. So this is the walkthroughs. This is the Fing machine. And we're going to be talking about this in just a little bit. Okay, so this is a walkthrough for the Fing machine on the vulnyx.com website. It is machine number 9 on the website. It is a low-level CTF box, and we're going to be doing a demonstration on how to finish the exercise. So the first thing we like to do when we test a CTF box is we like to run the nmap program to scan for whatever ports are open on the vulnerable system. So one thing that I haven't done is I haven't started the virtual machine, so I need to do that now. Okay, so I just need to wait for the virtual machine to start up, and then we can start hacking against it. Okay, so the Fing machine is up and running. The IP address should appear for me in just a second or two. So it says the IP address is 10.0.2.50, so that's the IP address we're going to be hacking against. Okay. All right, so we're running an nmap scan against that IP address. It is 10.0.2.50. It is on my network. And we're running the nmap scan with the following parameters. So we have -S for common scripts. So whatever services that it finds, it's going to try to run some common scripts against them to see if it's vulnerable to anything. We're going to run it with the -S V flag to see versioning information for whatever services we find. We're going to scan it against all ports with this option here, -P-, and we're going to see very verbose output with the -VV flag over here. And lastly, we're going to run it with 4 threads with this argument -T4, which means it's going to be fast, but it's not going to be too fast. So let's run our scan. So immediately we see that there are 3 services available on this host. And we're running our default scans, our default scripts rather. Okay, so before it comes back, let's identify these ports over here. So port 22 was found on the system, TCP. This is usually associated with the SSH service. We also found port 80 on TCP, which is associated with the HTTP service. That is websites without security. It is just the regular type of HTTP protocol. And we have port 79. So if anybody knows what port 79 is, then let us know. But otherwise, we're going to be talking about this service in just a moment. Okay, so we see that port 22 is SSH. It's running the OpenSSH software with version 8.4 P1 Debian. So we know that this is a Debian system that we're working against. That is useful information sometimes if we can't identify whether or not this is a Linux or a Windows or a Mac OS web server. So we also have port 79, which is reporting the finger service. So the finger service, we're going to talk about it in just a little bit. So finger, it says no one logged on. And we have we also have port 80 open, which is a web server, which is running Apache software with version 2.4.56. So this is relatively up to date. But the presence of this protocol right here, finger, is very unusual. So let's talk a little bit about this service. So over here, we're talking about the finger protocol. So the finger protocol is a service that can be found on network servers. It can be used to retrieve user data from the server. So what does this mean? Data that can be gained from the finger service can include the following. So usernames and real names, user login status, the home directory and shell of those users, contact information such as the address, email, phone number, and etc. of that particular user, and any .plan and .project files. So .plan and .project files are kind of like little messages you can leave, and the .project file is a file that you can leave on Unix and Linux servers to tell people what is going on with a certain project. So Finger is a service that was popular before the internet became popular, but is rarely found in modern network environments due to privacy concerns. So people can use Finger to get all sorts of information about users on the server. So this is why it's not used anymore. But in the past, people used to use it as kind of a directory. Okay, so let's what I like to do every time I encounter a new service or protocol to hack against is I like to go to the HackerFrogs website and I like to search for it. So I'm going to search for the Finger protocol on HackerFrogs and Finger pen testing Finger. Okay. So if you're looking for this website yourself, this is the web page we're looking at currently. Okay, so it says here pen testing Finger. So basic information, so it's a program service used for retrieving details about computer users. Okay, by default it runs on port 79 and it tells us how to do basic banner grabbing and connection to it. We can also use user enumeration. So it says here, alternatively, you can use the Finger user enum script from TestNucky with some example commands over here. So what we can do is we're going to try using the script to enumerate users on the system. So I'm just going to go over to this page. So it says Finger user enum, username guessing tool primarily for use against the default Solaris Finger service. All right, so download the software here. So we're going to copy the link and then we're going to move into our temporary directory. So I like to work inside a temporary directory when I'm doing CTF challenges, just so I don't clutter up my files, my file system with a bunch of stuff that I'm using to do this pen testing. So first of all, I'm going to download this file. So we're downloading this enumeration script. It's been compressed, so we need to uncompress it. So this is it over here. We're just going to unzip this file, and then it's also tarred. So we have to use tar with these arguments over here to untar the file. Okay, so this is the directory that is created, and all the files are copied to it. Let's move into that directory. Okay, so we've got our finger user enum.pl file. So this is a Perl script. Perl is a scripting language. It was very popular in the past, but it's not so popular anymore. But you'll still see some scripts floating around the internet that are written in Perl. And Kali Linux over here, this is the OS that I'm using, does have Perl installed, so we can run these Perl scripts. So I think to do enumeration, let me grab an example command syntax. So finger user enum.pl -u users okay. So we need to get a users list. So we're going to enumerate for users, so we need a word list with a bunch of usernames. So I'm going to locate seclists. So seclists is a bunch of different word lists for doing security testing, and I'm going to look for username. Okay, so seclist has a bunch of usernames. We've got 10 million usernames. Top usernames shortlist. Maybe I'll get this one with 10 million usernames. Okay, let's try this one. 10 million usernames. So we're going to copy this, and then we're going to run Perl finger user enum.pl with the user lists and this user list right here. I think this is all we need to do, but let me check. Oh, we need to supply the IP address, of course. So -t and then the IP address, which is 10.0.2.50, and we're going to run the script. So it's going to run. Okay. Hold on. So what I'm going to do is I'm going to run this, but I'm also going to output into a file called finger enum.txt. Okay, so that should be running. I'm going to move into my temporary directory, and I'm going to look at, so it looks like the file has not been, oh, I think I remember something about this box. So once you start fuzzing the finger service goes offline. So let me do netcat, and I think it's 79. Yeah, connection refused. So after you do some fuzzing against the finger service, the service goes offline, so I'm going to need to reset the box. So let me quit out of that command, and then I'm going to reset the box. Just a second. So the box is over here. We're going to turn it off and turn it back on again. Power off the machine, and then after it's powered off, power it back on. I haven't tested this machine in a while, but I forgot about that particular little quirk. Okay, so we just need to wait for this to come back online. Okay, so I think it is back up. All right. So we can do our, let me do an Nmap scan real quick, just to make sure that the finger service is back up again. Okay, that's all we need. Okay, let's run this. Let's run the finger enum script again, and we're going to output this into a file called fingerenum.txt, so we can look through it later. So I'm going to run the script. And then we should see, oh, it should be in the fingerenum. Okay, so fingerenum.txt is what we're looking for. So we can see the progress of the script over here. And what we're looking for is a user with a shell. So a user with a shell is probably going to be in the home directory. So we're going to grep for the pattern home. So we found a user, and the user's name is Adam. So Adam's directory is in /home/Adam. So we know that there is a user on the system called Adam, so we have something to go on. Unfortunately, if we were to look at the web page for this particular challenge over here, so 10.02.50, we see that there is a Debian default page here. So the Debian default page here indicates that there's no actual website here. There's a web server here. It doesn't actually point to anything. And if we were to do something like directory busting on this particular web server, we wouldn't be able to find anything. So once you run out of options, whatever you have left on the table is what you need to do. And in this case, the only information that we have is that there is a user on the system named Adam. So that means the only thing we have left to do is to do some SSH brute forcing. So SSH brute forcing means that we're going to try to brute force the password for the Adam user on the server. And in order to do that, we're going to run the following script. So this is the Hydra program. The Hydra program is used to get to brute force online services. So in this case, the online service that we're going to brute force is the SSH service. We know there's a user named Adam on the system, and we know the IP address. We're going to run it with at the maximum speed, just so that it doesn't take too long. But usually, this is a last resort kind of thing that we would do, because brute forcing SSH usually leads to lockouts, because there are a lot of SSH services that are secured by a program called fail to ban, and if your IP address supplies a number of incorrect SSH logins within a short amount of time, it will block your IP from accessing the server. But anyways, let's run the Hydra program. So this is going to run and try to brute force the program. It's going to try to log in as Adam using all of the passwords on the rocku.txt word list. So the rocku.txt word list is a very old word list. I think it was leaked out in sometime in the 2000s, and it has the top 14 million most common passwords on it. So whenever we do password brute forcing, we usually use a very large word list, such as the rocky.txt list. So we're going to wait a little bit for this to come back. In the meantime, I'm gonna put on some music. So I'm just gonna turn on my music, and I'm going to connect it to the stream. Okay, you should be able to hear it now. All right, so the reason we're running this with the 20, so the reason we're running the Hydra program with 64 threads is because if we don't run it with 64 threads, the process is going to go by very, very slowly. It's already going by very, very slowly, but on challenges where we have to do SSH brute forcing, it's not going to matter how quickly we try to brute force the SSH service if that is the intended way in. So that's why we're running Hydra at the maximum speed over here. If you have any questions about cybersecurity that you're burning to ask, go ahead and ask in the chat. We'll try to answer as best we can while we wait for the Hydra program to finish running. Just for fun, I think I'm going to put on another bird video. Oh, not this one. How about this one? So like I've mentioned before, these are Stellar Jays, and Stellar Jays are probably my favorite bird because they come around to my bird feeder, and they eat all the peanuts that I put out every day. But let's see. Okay. So yeah, so these lovely little guys, they come around, they like to eat peanuts. I've got this bird feeder that I put up in the backyard. It's made from an old coat rack and a bunch of bamboo sticks that I lashed together using zip ties. So this is my hacker version of a bird feeder. The most expensive thing is probably all the peanuts. They run me somewhere in the neighborhood of like $20 a month, but I think it's worth it if I see these guys come by every day and every time I see them hopping around and gobbling up peanuts, it just makes me smile. But they're always trying to get away with the maximum number of peanuts before they fly away. And let me check to see if the scan is finished running or not. Okay, so the scan is finished running. All right. So the Hydra program is finished running against the Adam user, and the username is Adam, and the password is Passion. So we just need to remember this. We're going to use this to log into the SSH server. So it's going to be SSH Adam at this IP address. So we managed to brute force the password. The password was Passion, so I'm just going to type in passion as the password, and we are in. Okay, so I just need to put on my voice changer so that I can do my scary hacker voice. So let's see, the voice changer is here, and then we need to do the voice changer.
Hey everybody, this is my scary hacker voice. I put this voice on every time I break into a web server, so I can put on my scary hacker voice and say, I'm in.
And then I go back to my normal voice. Alright, so we're in. So Adam at Fing over here. So the first thing we like to do when we break into a web server is we like to run the sudo l command to see what sudo permissions we have as a current user. So it says orden no encontrada. This is Spanish, I think. It means command not found. The music is a bit loud, so I'm going to turn it down. Okay. Alright, so the second thing that we do is we look for any SUID binaries. SUID binaries are binaries on the system that run with elevated privileges. And I think, let me look up how we find these, because I keep on forgetting. So it's a find command, find SUID binaries. And the command we're looking for is this right here. So this is going to find SUID binaries on the system. So it's files with this particular setting with its permissions. So perm equals u equals s. S I would suppose is the SUID bit. Let's search for those. Okay. So anytime we do this kind of scan, we probably want to inspect these binaries closely and see if these are binaries that have any vulnerabilities associated with them. So we could look through these one by one. If there's something that is super stands out immediately, we might be able to point that out. But if you're not sure, you can always just highlight the entire list over here and feed this to something like ChatGPT. So we can go over to ChatGPT and ask it, this is a list of SUID binaries on a CTF server. Are any of them unusual? And then paste in all of the list of binaries. And then ChatGPT will probably, most of the time it is able to point out if there are any unusual binaries in the SUID list. Okay, so it talks about most of these binaries, and it's going to tell you that most of these binaries are very normally set as SUID binaries. But there's this one over here that stands out as potentially unusual. Do as is an alternate to sudo and is often used on BST systems. It's also available on Linux. So what is this binary over here? Let's talk about this while we get ready to do our privilege escalation. So privilege escalation, SUID do as. Do as is a Unix Linux program that allows a user to run commands in the context of another user. It is similar to the sudo command, but do as has a much simpler setup process. So the configuration for the do as program can be found in the etc/doas-conf file. So let's take a look at that now. So on the system, we're going to cat /etc/doas.cnof-conf, and it says this, but what does this mean? Let's take a look. So for this example, in this configuration, without providing a password, keeping the current environment variables the Atom user can run as the root user the user bin find command. So over here, permit no password, keep environment, Atom user as root, this command user bin find. In this example, the user can run the find command as root, and it can be used as a method of privilege escalation through doas. So, because we can run the find command as the root user, we're essentially running sudo find, the sudo command with the find program. So the find command is used to locate files and directories on a file system that match specified parameters. One feature of the find command is the ability to run system commands on the files or directories that it finds. So if a user can run it with sudo, it can be used to open a root shell with the above command. So if we were to do sudo find on the current directory, and anything we find, we run the following command: bin sh, which is opening up a shell. Because it's running as sudo, this is going to be a root shell, and then after it finds the first thing, it's going to quit. So let's do our privilege escalation. So for privilege escalation, we do sudo, no, we just do as. I forget the syntax for doas. Let me look in my notes. Okay, so just need to grab my notes. Need to go to my write-ups for VulNyx. Below. Okay, so so the syntax for using doas is the following. It's doas and then -u and then the user that we're going to do as, which is root. We're going to run user bin find, and we're going to run this on the current directory exec, which is to run the bin sh binary, which means we're going to open up a root shell. So afterwards, after finding the first example, we're going to quit. So this is the way that we use doas combined with the find command as root to open up a root access shell. So when we run this, we see that our prompt has changed. It is now the octothorpe over here. We ask who am I? We are root. So that means we can redeem this fun video redeem, which is I'm root.
What are you?
I'm system root.
Okay, so we're now root. So we've almost finished the exercise. So to finish each one of these exercises, we need to move into the root directory, and we have somebody on Kick chat. On Kick chat, MattX69 says, "Hi sir, I hope you're doing well. I'm new on this platform, and when I search for cybersecurity stuff, you are the one that appears. We love the content. Keep it up." Thank you very much, MattX69, and nice to see you on Kick. This is not my primary platform, but I appreciate all the viewers on Kick as much as people on YouTube and Twitch. All right. So we've moved into the root directory. We see here that there is the root.txt file. And normally what we would do to finish this exercise is to read this file. But we're not going to read the file because the organizers over at the VulNyx website don't want people who do video walkthroughs and write-ups to reveal the contents of the flags. So what we're going to do instead is we're going to cat root.txt, but we're going to redirect that into a file called ireadroot.txt, and we're going to see that both the ireadroot.txt file and the root.txt file have the same file size, And we're also going to run md5 sum on root.txt and I read root.txt. And we see that the nd5 sums are the same for both of these files, which means that we've essentially read this file and completed the challenge. Cybernerd Dante says, I am Groot. Thank you very much. Thank you very much. Okay, so, alright, so that was the Fing challenge from VulNyx.com. So we got in by abusing the finger service, and after we got in, we abused the SUID binary do as well as in combination with the find program to get privilege escalation and open up a root shell. Thank you very much, and we still have about 20 minutes before the next class, so let's start in on our next box. So the next box we're going to cover is, let me exit out of here. Okay, let's move out and remove all this stuff. Need to keep our file system nice and clean. Okay, so the next challenge we're going to do is the basic challenge. So the basic challenge is also on VulNyx, but this is a challenge that I haven't completed yet. So I am more than likely going to get stuck on the challenge at some point. I think this is challenge number 54. Number 56. This is challenge number 56 on the website. And if you want to do this challenge yourself, then you can access the VulNyx website over here. Okay. But in order to start the challenge, I need to start up the machine on my box. The Feng challenge is done, so I'm going to close the virtual machine, and I'm going to start the virtual machine with basic. Okay, so the machine is starting up. So the basic machine over here is all about doing pen testing against a printer. So I've never done pen testing against printers before, so this is going to be an interesting challenge. I'm probably not going to be able to finish it today because I don't have any experience pen testing printers. But the machine is going to be at IP address 10.0.2.49, so that's the IP address I'm going to be hacking against. So let's do our preliminary scans. So the first thing we want to do is go into our temp directory. So the first thing we're going to do is we're going to run an nmap scan, and the nmap scan is going to be with these flags over here: -sc for common scripts, -sv for versioning information, -p- for all ports, -vv for very verbose output, and -t4 for very fast speed. So we see that there are 3 ports running on the system. We've got port 22, which runs SSH. Lunchbox XL, Lunchbox 3XL says good evening. Good evening to you, Lunchbox 3XL. So we're just going to do some a little bit of hacking against this system over here before we start our next class. And the next class is going to be in about 15 minutes, but we have a little bit of time. Let's see. So on port 22, we've got OpenSSH version 8.4. This is probably not vulnerable. Port 80 is running Apache HTTP D 2.4.56. This is also relatively up to date, so probably not vulnerable to known exploits. But we also have this cups server over here. So this is reporting cups 2.3. It's running cups 2.3 IPP 2.1, Cybernet Dante says, just a heads up, you're not showing up on InfoSec streams. Huh, that's interesting. Let me check. infosecstreams.com. Oh, I'm not on the list. That's funny. I'm on the list, but it doesn't show me online. I wonder why that is. Well, I might have to do some further investigation later. But thank you very much for giving me the heads up. Okay, so this is CUPS 2.3. So CUPS is a Lunchbox 3XL says it's conspiracy. I hope it's not a conspiracy. But let's see. IPP 2.1. This could, so CUPS is a version of IPP. IPP is Internet Printer Protocol, and CUPS is, I think it's the Unix printer service or something. Anyways, let me search whether or not this version of IPP is vulnerable. So we can do search exploit and then the name of the service and then the version information. So IPP, I guess IPP is not, we would have to search for CUPS. CUPS. So CUPS is the printer service. So CUPS 2.0, CUPS, so this is probably not vulnerable because we're working with CUPS 2.3, and none of these vulnerabilities here indicate anything 2.3 or over. So it's probably not this. We need to do some curl. So we're going to run curl to retrieve the web page. For some reason, I tried last night to take a look at this in my web browser. It doesn't render on the web browser. If we go to HTTP 10.02.49 on port 631. Oh, what? I wonder why this didn't work for me last night. Oh well, I guess I didn't try hard enough. Okay. So we've got all of these endpoints over here. Oh, interesting. It's the observer principle. Now that we're observing, it works. Yeah. If your software is doing something weird, then if you have somebody look and watch over your shoulder, then it doesn't appear anymore. Okay, so let's see. Man, my music was going at 2 times speed this entire time. That must be disorienting. Okay, so search in firewalls. Can I search for something? No matches found in firewalls. Okay. So we've got all these endpoints. What could we try? View printable version. Firewalls. Is there a login form? User forum overview of CUPS. Command line printing and options. So maybe we could abuse this. Printing files, choosing a printer, setting the default printer, printing the output of a program. Creating saved options. Printing multiple copies, canceling a print job. Oh man, I sure do love printing. Setting the orientation. Okay, so one thing. So I asked ChatGPT what we should do when we do security testing against printers, and one thing that it told us was attempt basic directory traversal. So some CUPS versions are vulnerable to directory traversal attacks, allowing attackers to read arbitrary files. For instance, this over here. So we could try to access a legitimate endpoint and then try to do directory traversal. So I guess in this case, we could try accessing the help endpoint, but then do a directory traversal attack. So we do curl and we // it up. And then we try to access the etc password file. So not found. Not found? Okay. So it says not found. Not found, but if we just access the help, then it's going to return us the Spanish version, because I guess on the server we're working in Spanish. Okay, so now that I think that directory traversal is ruled out, what else could we try? So identify the CUPS version. Okay, we've done that. Check CUPS for web interface access. Yeah, we're able to interface with it with the CUPS interface is accessible. Enumerate any printers or queues configured on the server. Cybershell says, "Hey, que aprender español." I do not speak Spanish. No comprende español. But this is we're working with the VulNyx platform, and the VulNyx platform is Spanish. I think the platform creators are Spanish, so all the machines have are written with the Spanish version of the OS. Okay. All right, we've got a few. We can pen test for a few more minutes before we have to get ready for the next class. But let's, you know what we should do? Cyberner Dante says something, maybe there's some cool parameter requests if you open up a proxy like Burp Suite. I think I'm going to try something a little bit simpler than that, first of all. So I'm going to run Nikto on the endpoint. I'll run Nikto on the endpoint. 631, and see if we can identify anything. So what we can also do is we can also try running dirb and dirbuster. So we can dirb this 631. Okay, so we were able to find some. Oh, there's a robots.txt file on here. We were just talking about robots.txt in an earlier class, so maybe we can check out the robots.txt file. Did Nikto find it? Nikto didn't find it. Oh, it hasn't found it yet, anyways. But let's try looking at the robots.txt file. There's also a login portal. Right. Let's see. So let's go to robots.txt. This file tells search engine is not. So this doesn't help. This doesn't help, but that's okay. We know that there's. Where was that login portal? So let's see. Admin pro, admin panel, admin login. I guess admin SQL. There's a lot of stuff here. Let's do admin panel and then admin login. Admin panel. Okay, so this is the admin panel. Classes, help, jobs, printers. So what can we do with this panel? Add printer, find new printers, manage printers. Interesting that all the admin are 4904 size. It's probably because they all redirect to the same page. That's my guess. Edit configuration file. Maybe we can look at the configuration file. So there's a configuration file here. Does it have any sensitive information? Okay, I don't see anything super juicy. So I guess I'm just gonna back out. Edit configuration file, server settings advanced, share, allow users to cancel any job. What are the advanced settings? Share printers, max clients, allow printing from the internet, advertise web interface. Manage jobs. Oh, maybe we should take a look at the jobs. Okay, so show completed jobs. There are no completed jobs. Show active jobs. There are also no active jobs. Show all jobs. There are no jobs. Okay, let's look at the printers. Oh, we've got Dimitri's printer. Interesting. So Dimitri is probably a user on the system. So we might be able to do some SSH brute force on Dimitri's login on the system. Okay, so we're going to put a pin in this, and we're going to be coming back to this after about an hour or so. I need to get ready for the for my HackerFrogs class. So the HackerFrogs class is actually, you all might find this interesting because we're going to be learning about OS command injection. If you don't know about OS command injection, or if you want to brush up on your OS command injection skills, then you can stay tuned for the HackerFrogs class. That's going to be going on. It's starting in a couple minutes and going for the next hour. After that hour is up, we're going to come back to hacking against this system over here. So let me grab the files I need to do the class. So HackerFrogs After School, this is web app session 4. Okay, web app session 4. I also need to grab my notes. Session notes. Batch 1, web app hacking, session 4. Okay, so if you're here for web app hacking, please type in the chat web app hacking, smiley face, and then I'll know that you're here to learn about web app stuff. Web app hacking, smiley face. Cybershell asks, maybe a super dumb question, but can you explain how your classes work? I've seen that you do several classes in one day, so how does that work? Web app hacking for life. Well, I've got a schedule that I put on my Reddit and on my YouTube. So let's see, HackerFrogs. So each week we have a schedule. We also, if you take a look at this week's schedule, we publish the weekly streaming schedule usually on Friday. Usually on Friday evening after I finish up my my stream on Friday. But we've got Web App Hacking Basics session 2, 3, and 4 this week. Next week we're going to do Web App Hacking session 5 and 6. On Monday it's a holiday, so we're going to be taking. We're not going to be doing the HackerFrogs class, but we're going to be doing another class. We're not going to be doing a class. We're going to be doing some more live hacking demonstrations on Monday, which is November 11th, which is Veterans Day in America and Remembrance Day in Canada, where I live. But anyways, I hope that answers your question, Cybershell. The classes are usually at around this time, so 5 o'clock, Pacific Standard Time, which is 8 o'clock Eastern Time. And Cybershell asks, what is the main difference between the after-school classes and the other ones? Are they knowledge-based? I'm not too sure what you mean by knowledge-based. If you can elaborate on that, I could answer your question. But the after-school classes are beginner-friendly classes, and the other hacking stuff, it's also beginner-friendly, but it's a lot less explanation about what's going on. Knowledge level. Everything I do on this stream is going to be aimed at beginner-level students. So if there's anything that you don't understand, any of the terminology, and if I start talking about stuff like protocols or services, and you don't quite understand, please ask me. I'll try to answer as best I can. But let's start our class. Okay, so this is... Ooh, I'm going to turn off the music for the duration of the class. Okay, so this is Web App Hacking Basics Part 4. So this is the 4th Intro to Web App Hacking workshop. In the previous workshop, we learned about the following web app hacking concepts. So we learned about source code analysis. Source code analysis is the process of analyzing a piece of the code of a piece of software with the goal of deeper understanding regarding its function. So we took a look at the Natas CTF challenges, and we were able to take a look at some code. And through the code, we were able to figure out what we were trying to do inside those challenges. It is a common technique used in software security testing, but it requires the software source code be readily available. So people might not know this, but when web app security companies test against very large web applications, sometimes the application developers will give the security testers a copy of the source code for the app, and the security testers are able to take a look at the source code and the code base and determine if there's anything insecure happening inside the code base. So this is a more cooperative kind of security testing, but it is much more effective than having the security testers go in blind, and this is where source code analysis can be very helpful. We also learned about URL parameters. URL parameters are variables attached to the end of URLs. They are often used to send search queries to web servers, but they can also be used to retrieve other data as well. Cybershell says, understood, thank you, thank you. CyberNerd Dante says, this is white box testing. That is correct. So white box testing means that the testers have access to the source code of the application that they're testing. Gray box testing is kind of in between, and black box testing means that the security testers are sent in blind to test against the application. So we also learned about local file inclusion, otherwise known as LFI. This is a web app vulnerability where arbitrary local web server files can be accessed through a web interface. So let's continue where we left off. So we're going to continue where we left off in the Natas CTF on Natas level 8. So if you want to join in, you can take a look at the GitHub page over here, and the GitHub page is going to have a link to all of the exercises we're doing. Keep in mind that we're also doing a Try Hack Me room today. So if you do not have an account over at Try Hack Me and you want to participate in today's session, please create an account over at tryhackme.com. But we're going to do the Natas 8 challenge. Hold on. It says here in Natas 9. Maybe we're doing the Natas 9 challenge right now. Hold on. Okay. Let me do Natas 8, Natas 9. Let me get the notes from the last session just so I make sure that I'm using the right thing. Okay, so we did Natas 8 in the last session, so we're going to start off with Natas level 9. Right, so everybody, the link for Natas level 9 is right here. The username is Natas level 9. The password is this thing right here. Let me provide it to everybody in chat. Okay, so this is Natus level 9. It's going to ask you to log in with a username and password. The username is Natus9, Natus9, and the password is the password that I pasted in chat. Let me copy that. Okay. All right, so if you're following along, you should see this web page right over here. And if you can see this web page, because you logged into Natus level 9, please type in the chat, Natus 9 is alive. Smiley face. Okay, so what exactly is going on this page? So we've got this this web form over here. It says find words containing, and then there's a field, and you can click on the search button over here. Okay, Cyberner Dante says Natus 9 is alive. Great to see. Okay, so if you were to type in your test string over here, click on search, so then it's going to give you this output over here. It looks like a bunch of words where the word test is included in the word. So adroit test, adept test, aq test. Okay, so we can go back and we can see that we can also take a look at the source code for this page as well. So if you hover over the link and then put the link in a new tab, you're going to see that this is the source code involved in this app over here. So can anybody identify what kind of code this is? So this particular tag should be a big hint as to what kind of language we're dealing with. So this is not HTML, this is not JavaScript, this is something else. Can anybody identify what this is? So Cybernerd Dante identifies that this is PHP, and Linux Girl also identifies this as PHP as well. Great to see you here, Linux Girl and Cybernerd Dante. But yeah, this tag over here is a clear indication of PHP code. So if we see over here that what is going on inside the code, we see here that there's a variable called key, and it's equal to this empty string. So we do an if statement, if array key exists, needle. So I'm guessing that whatever parameter that we send to the web app is called needle. So if this exists in the request, and this key variable is going to go from the empty string to whatever is the needle value in the request. So if the key is not the empty string, then we're going to run this function right over here, pass through. So does anybody know what the pass through PHP function does? And if you don't know what the pass through PHP function does, do you know how you can find out? I can ask the Google. That's correct. So, well, I'm going to go a step further. I'm going to ask the GPT. So I could ask something like, what is this PHP function doing? And it's going to give me an answer. So the pass-through function in PHP executes a command in the shell and outputs directly to the browser or terminal. Here's a breakdown of what the particular line does. So what this does is it runs this Linux command. So the Linux command being used is grep I key dictionary.txt. So grep I is for case insensitive, I think. So whatever you provide, it's going to look inside and grep out anything from the dictionary.txt file. So why is this? So what can we do to potentially break the security of this web application. So let me get out of here. Where are we? Here? No, here. Okay. So why is this code insecure? Does anybody know? If you don't immediately know why this code is potentially risky, that's fine. We'll talk about it in a little bit. Cybernerd Dante says no sanitization on the key variable. I think. Well, that is exactly it. Yeah. So we're going to be talking about what can be exploited on this particular app, and we're going to be talking about OS command injection. So this is OS command injection. It's a web app vulnerability where arbitrary OS commands can be performed on the web server through a web interface. So OS command injection is a serious vulnerability and can often lead to complete compromise of the web server. And if so, the web server can be used as a foothold to attack other machines on the network. So if you're able to just do arbitrary command injection on a server, then you can very easily get shell access to the web server, and that's a very bad thing. So let's take a look at what command we can do over here. So we're just going to exit out of here. And one thing that if we suspect that we're able to do OS command injection on a particular app, we could send a couple of test payloads. So this over here, this semicolon is going to stop whatever, it's going to end whatever command is being inputted, and we can input our own command. So we could send who am I, and then we can comment out the rest of the command over here. So if we were to give this command here, it's going to give us the output natas9. So natas9 is the user in this case because we gave the who am I command. So we could send all sorts of we could get all sorts of information about the web server. So we could get the host name, so which is called natas. We can also get we can get all the users on the system with this command over here. We could read the etc password file, and this tells us all the users on the system. And so basically, if you can do OS command injection, it's very bad news. But the thing is that we want to access a very specific file by using OS command injection. And let's do a breakdown of what that command is. So we're going to run this command to read the password for the next level. So maybe this is not immediately, this is not something we covered recently, but the passwords for all of the next levels in the natas CTF game are located in this directory right here, the /etc/natas_webpass directory, with the name of the user's password we want to access as the last part. For example, for the natas10 password, it would be in this directory, in this file right here. So the anatomy is the semicolon terminates whatever command is being run. The cat command is going to read the file. This is the file path to the natas10 password file over here. And the hash symbol is going to comment out anything that follows afterwards. So we're basically injecting into the Linux command that's being used. So let me get that Linux command again. So what we're doing is we're injecting right over here. So the key is the user input. So grep I, we're going to get out of this command with the semicolon, and then we're going to run our own command. And then the hash symbol is going to comment out the rest of the command over here. So that's what's going on when we run this command. So let's run the command and then see get the password. So this part is the same. We're going to cat etc natus underscore webpass and natus 10. Okay, so this is the string we want to send to the web app. And just in case you wanted to copy and paste, that's it. So we were able to read the file on the web server and get the contents. The contents are the password for the next level. So we just need to grab this password and then go up to the URL and modify it so that we go to natus level 10. So just modify the address so it says natus level 10, hit enter. The username is going to be natus 10. The password is going to be the thing that we just copied. And then click on sign in. And then we're finished. All right, so everybody, if you managed to steal the password and then log into natus level 10, please type in the chat 10 out of 10. Smiley face. Summer Dante, 10 out of 10, but I have a question. The conditional says that if the key is not empty, it will conduct the operation, but there's no else statement. Yeah, so there's no else statement in the code here. If key, then it's going to run the command. Otherwise, so else nothing. So it's basically else nothing happens. That's what I'm guessing. So let's see. Summoner Dante says, aren't we sending an empty statement? No, we're not. We're sending code. We're sending OS command. So the key over here is populated with our OS command. It starts empty, but when we send the request, the needle key is populated with whatever code we supply, and that populates the key variable. Okay, so let's go over to the next level over here. So this is natus level 10. So it says here, for security reasons, we filter on certain characters. So find a word containing something something. So this looks almost identical to the app that we were looking at in the previous level. So we could try to feed it the OS command injection payload from the previous level. But when we try to do that, it comes back, input contains an illegal character. So what are these illegal characters? We need to find out. So let's go over to the view source code one more time. Let me get rid of this one. Okay, so view the source code in a new tab. Okay, so this is almost identical to the previous level, except we have a couple more if conditions over here. So the start of the code is the same, but if the key is not empty, and if preg match these characters right here in the key, then we're going to print input contains an illegal character. Otherwise, we're going to run pass through this function grep I key dictionary.txt. This is the same, but first it's going to check for these characters. So the characters are the semicolon, the pipe, and the ampersand symbol over here. So if it detects any of these are in your user input, then it's going to error out and say input contains an illegal character. So let's test this. So we're going to try the what was it? The semicolon, okay, and the pipe. and the ampersand. So we can't send any payloads that include that character. So how can we get around this? Does anybody have an idea how we could get around these restrictions? So the key to solving this level is knowing that we can't use the semicolon, the pipe, and the ampersand character, but we know that this is the Linux command that's being used. So grep I, our user input, dictionary.txt. Okay, Summer Dante says, let's try encoding the payload. Okay. We could try encoding the payload. I think we could do, what was it, URL encode? So first of all, let's try URL encoding the semicolon. And we can encode that, and it turns into %3b. Okay, so we can copy that, go back to the app, and send it %3b. Okay, it didn't give us, oh, so we could try %3b, and then maybe who am I? Is this going to work? No, no, that's not going to work. Huh, for some reason, I wonder why that doesn't go through. Oh, wait. We can also put this hash symbol at the end. And that didn't work either. Okay. So let's try encoding the entire thing. So if we do something like semicolon, who am I, and then hash, and then URL encode the entire thing, then it turns into this. So we could try feeding the application this. For some reason it doesn't, nothing appears when we URL encode it. So, I mean, we could try encoding, but URL encoding doesn't seem to be working. But there is something else that we can do to finish this level, and the key lies in the Linux command that is being run over here. grep I key dictionary.txt. Okay, Linux Girl says, not sure why we're doing this, just use the grep command. That's right, we just have to use the grep command. Yeah, Linux Girl has it completely correct. So we can use the grep command, and we can use the grep command not only on dictionary.txt, but we can use it on multiple files. And if we use it on multiple files, we just need to include one letter that is in the password, and we're going to get the entire password. So we can go over to, let me demonstrate what the payload is going to look like. So the payload is going to look like this. So first of all, there's going to be an argument to the grep command. We're going to search for the letter A. 2 is the file to be searched. We're going to search inside the natus11 password file, which is this one right here. Next, we're going to use a hash to comment out the rest of the command. So the rest of the command is the dictionary.txt. We're going to omit that, and we're just going to search for the letter A inside of the password file over here. So let me just grab the payload. If you want to try it out yourself, here you go. So let's go over to the application. So what we're doing is we're actually using the grep command. We're using the grep command because we can't use the pipe, and we can't use the ampersand symbol, and we can't use the semicolon. So if we run this, then we get the password because the password has an A in it. So the A is right here. And that was bypassing the filter through using the grep program in its intended way. Okay, so we can just highlight the password over here and we can log into the next level. So here we're going to replace NATIS 10 with NATIS 11, and we're going to get rid of all of this stuff over here. It's going to ask us for a username. The username is NATIS 11, and the password we're going to paste in. And then we are signed into NATIS level 11. So we're not going to. This is actually the last NATIS level we're going to be covering. Well, NATIS 10 was the last one. NATIS 11 gets a little bit more complicated, and we're not going to be covering this. But we're going to be covering more challenges that have to do with OS command injection. So if you manage to log into NATIS level 11, please type in the chat. It's 1111. Make a wish. Smiley face. All right, so we're going to do a couple more exercises using OS command injection, and I think one of them is going to be a picoctf. Let me check my notes. Okay. Oh, we've got two of them. Interesting. Okay. All right, so we're going to do a picoctf challenge, and if you don't have a picoctf challenge, you can make an account right now, because it doesn't take very long to create an account over at picoctf, and picoctf is also free, so you don't have to worry about paying for anything. This first challenge is called Login. So it says, my dog sitter's brother made this website and I can't get in. Can you help? And we've got this this login page over here. Does this have anything to do with OS command injection? I don't remember. Maybe. Let's solve the challenge anyways. If it doesn't have anything to do with OS command injection, it probably has something to do with some other stuff we learned. All right, so we're going to put this in a new tab. And you can just, I think you can just log into this page over here. So we've got our username and password. We're going to do test, password test, incorrect username. Wait, are these challenges? These might be challenges from last week's session. Let me take a look. This is from this session. Okay. Let's try to figure out this challenge over here. So username and password, we don't know, but we can take a look at the page source. Oh, okay. So we've got some other files we can look at. So install.css and index.js. So I think the problem here is the if the login function is in index.js, then that's a big problem. So let's click on this and see what's going on in this. So wrap long nines, yes. Syntax highlighting, yes. Okay, so what's going on in this password? And what's going on in this JavaScript? So is this correct password? Your flag is this. So this is probably encoded. Username and password. So this is probably the username and this is probably the password. let's try base64 decoding these. So if we go over to a website like base64 decode, and paste this in and decode this, then we see picocts server server server. So this is actually reference to server-side code, and server-side code should not be used for security because it can be modified, or it can be viewed rather. So this is probably the password. So just for fun, we're going to go back and insert this as the password. For the username, it's this. So we probably need to base64 decode this as well. I think this is admin, but let's make sure. This is admin. Okay. So we can just go back and put in admin as a username and the thing that we pasted in as the password. Click on submit. Correct password, your flag is this. Okay. So to finish the challenge, we just need to... Oh, we can't highlight. Can we highlight this? Okay. Sarah Dante says, "Well, you remember base64." Well, I mean, base64 is a pattern, right? So this looks like base64. It doesn't have the equal signs at the end, but the character set is correct. It's uppercase and lowercase letters and numbers. So this qualifies as base64. As far as this is concerned, I'm just guessing that this is admin because it's a very short username. Anyway, we've got the flag value, so we can go over to login, paste in the flag value, click on submit flag, and then we're finished. Okay, the next challenge definitely has something to do with OS command injection, and let me grab that. So the next challenge is CAAS. Okay, so everybody, you can access it from this web page. Okay. This seems to be... The server doesn't seem to be very responsive. Hold on. Okay, I'm gonna try... Alright, okay. Okay, so the description in the challenge says, now presenting cow-say as a service. Alright, so we also have some a challenge endpoint. What is this? Source code file, index.js. So if we wanted to cheat, we could probably look at the index.js file. So let's put this in a new tab. Index.js. Okay, so we're going to open up our web shell just to take a look at that file. And so I'm going to copy the link, and then I'm going to open up my web shell. So in the web shell, and we can put the web shell in its own browser tab like this by clicking on this button called Pop Out Web Shell Terminal. This is going to give us a Linux web shell to work with. So I'm going to get rid of the stuff that's already in here, and then I'm going to download the file. So wget space, and then paste in the link for index.js. So after we finish downloading the file, And if I'm going too fast, or if there's any commands that you don't quite understand that I'm using, go ahead and let us know, and I'll try to answer your questions as best I can. So we've got the index.js file in here. What we want to do is we want to take a look at the file with, what is it called? Syntax highlighting. So what we're going to do is we're going to use nano to take a look at the file. So nano space index.js. Okay. So this is a JavaScript file. So I'm not very fluent in JavaScript. So I'm just going to guess what is going on. So constant express equals requires express. So I'm thinking that something is being imported here. The app equals express. This is a function call, and we're going to exec required child process. So child process makes me think that this could be something that runs system commands because it's creating a process. So app get cowsay message, and then it's going to run a command. It's going to run on user game. It's going to run user game cowsay, and then it's going to say the message. Okay, so if we were curious, if we didn't know JavaScript, and I don't know JavaScript, I'm just kind of guessing at what's going on, we can just highlight all this and we can feed this into ChatGPT because we're dirty cheaters. So just copy, it doesn't like that. Just highlight all this and then copy and then go over to ChatGPT and ask, what is happening in this JS code? And then paste in the code, and then ChatGPT will hopefully explain what's going on. Okay, it creates an Express server that listens on port 3000 and allows users to pass a message to the cowsay program via the URL parameter. Okay, so this is setting up the website. Now create the server from and exec from node's child process module to execute shell commands. So the child process is basically running commands and creating new processes. So it's going to serve static files from the public directory, if it exists. All right. So it's going to listen for GET requests at the /cowsay message endpoint. So this is where we're going to be doing our command injection. So rec params message captures the message parameter from the URL. Exec then runs the cowsay command with the message provided by the user, and a 5-second timeout is applied to prevent long-running commands. If an error occurs, the server returns a 500 status. Otherwise, the server returns the output of the cowsay as plain text. Okay. So ChatGPT has already identified that there are vulnerabilities in this code, and if we sent the parameters delete everything on the file server, then bad stuff could happen. So let's take a look at what the application looks like in action. So back over at picoctf, over here. Right. Okay. So cowsay as a service, we can put this in a new tab, and it says over here, make a request to the following URL to cowsay your message. So this one over here, it's the same thing as this endpoint right here, but we have to give it a message. So can anybody suggest anything that we should send as a message to get command injection? So let's just HackerFrogs rule. Okay, so it sends this message right here, HackerFrogs rule. It does accept spaces in the input. Okay, but what we can do is we can get command injection. So what payload would we send to get command injection in this case? Can anybody recommend an appropriate payload? So first of all, we should probably just send a payload to make sure that command injection is available on the system. Okay, so Cybernerd Dante suggests HackerFrogs rule, and then semicolon, who am I? Okay, that worked. So it sends HackerFrogs rule, and then it returns the user that we're working as, which is Node. All right, so in order to figure out what's going on, we probably have to read some sort of file to get the flag for this challenge. So we probably want to run the ls command. So we can, I think what we can do is we can just send, let's see, semicolon and then ls as our payload. Did this work? Or did this? Oh, it didn't like that. It didn't like that. Okay. So we need to send a legitimate message. So HackerFrogs rule and then semicolon ls. Okay. So we see the contents of the directory here. There's yarn.lock, public, package.json, node modules, index.js, and this flag right here, fulg.txt. So we can just read that. So we're going to send this payload, HackerFrogs rule, semicolon, cat fulg.txt. And the flag is picoctf moo. All right, so let's finish the challenge by copying the flag and then going over to the challenge page. In the challenge page, paste in the flag, click on Submit Flag, and you are done. If you managed to finish that challenge along with us, please type moo smiley face in chat. All right, so we're going to do one more. We're going to do one more challenge in order to cement our knowledge of OS command injection, and the challenge is going to be on the Try Hack Me website. So if you don't have an account at Try Hack Me, you can go ahead and make one right now. It is completely free. Well, you can pay for it if you like, but the stuff we're accessing is completely free. So it's at tryhackme.com. And you need to log in. So let me log in. So I am gmail.com, and I need to get my password. Just a second. I am not a robot, thank you. Log in. Okay, so the challenge we're looking for is over here. Wait, this is not it. This is it. Okay, this is the link. Where's my Try Hack Me? Here it is. Paste in. So this is the DVWA room, and the DVWA room is basically a damn vulnerable web application. It's got a bunch of different challenges that you can. It's got a bunch of different vulnerable applications that you can test against, and in this case, we're going to be running the OS command injection challenges on here. So what you need to do is, after you've logged into TryHackMe and you come out to this page, let me demonstrate how to join the room, just in case you don't know how to do that. So what you need to do is you need to click on this green Join Room button. So after you've done that, then you can access the stuff in the room. Click on the Task 1 banner and click on the Start Machine button. So click on the Start Machine button and then go up to the top of the web page and then click on the Start Attack Box button. We're going to need to use an attacking machine to interact with this vulnerable web app. So just click on that button, Start Attack Box. It's at the top of the page. And that's going to start up your attacker machine. So the attacker machine is going to take about 2 minutes to initialize. If you have your machine initializing, please type in the chat, starting the attack box, smiley face. And that's going to take a couple of minutes. In the meantime, we can talk about all the interesting stuff that's happening in our lives, or not. Or I can put on a bird video. This is my favorite thing to do. How about this one? This is Stellar J. He's I think this is sometime in the summer. This guy's a fledgling, actually. You can tell that's because the coloring on his feathers isn't completely black yet. We're just taking a look at this video for a couple of minutes while the machine starts initializing. So if anybody doesn't know, this is a Stellar J. It is the West Coast version of the Blue Jay. Blue Jays are on the East Coast and Stellar Jays are on the West Coast. I don't know if they have an East Coast West Coast rivalry like a lot of sports teams do, but they're really cool birds. And this is an eastern gray squirrel. So you might say that this is not an eastern gray squirrel because the squirrel is black or gray, but eastern gray squirrels can have a variation of their fur color, which is black, and this is a mutation that is quite common in eastern gray squirrels. Seminator Dante says this must have been what I saw on the way back from Oregon. Yeah, they are certainly in Oregon. All right, so your attack box should be initialized now. And after initialization, you're going to see this terminal over here. So just click on the terminal and hit enter to dismiss this dialog box. Mr. Diesel Doug just subscribed on YouTube. Thank you very much for the subscription, Mr. Diesel Doug. Okay, so after the machine is finished initializing, you can put this attack box in its own browser tab by clicking on this button. The button is called View in Full Screen. It's in the middle of the screen on the bottom. Just click on that. And that's going to put the attack box desktop in its own browser tab. So after you've done that, go back to your original TryHackMe page and click on the minus button down here. So at the bottom here in the split view, click on the minus button to exit the split view. Okay, so now you should have the target machine information banner on the page here. It shows you a target IP address. And on the other tab, you should have the attack box. And in the attack box, you can click on the Firefox tab to open up the web browser inside the attack box. Okay, so it says, well, okay, it says this, but what we want to do is we want to get the IP address from the other page. So on the other TryHackMe page, at the top of the page, there should be the red banner here, Target Machine Information. So under Target IP Address, I want you to click on the Copy to Clipboard button over here, then go over to your attack box. In the attack box, after you start up your Firefox, and in the IP address, then the URL address bar, paste in your IP address. That doesn't work. Okay, go over to this button over here that's labeled Hide Show the Control Bar. Click on that, and then click on this clipboard button. In the clipboard here, paste in the IP address, and then close this tab, and then go over to the URL address bar, and then paste in the IP address. Okay. And you should see the DVWA logo after you paste in the IP address in your attack box web browser. So if you see it, please type in the chat DVWA smiley face. So right now I'm working in a virtual machine, inside a virtual machine, in a web browser, So Exhibit would be very proud. If you're having problems with accessing any of the technology here, please let us know and we'll try to help you out. So the username here is going to be admin, and the password is going to be password. Then click on the login button. Okay, so after you've logged into the DVWA app, you need to navigate to the bottom of the page. And in the sidebar, there's going to be this button labeled DVWA Security. You need to click on that. So after you've clicked on that, it's going to say that the security level is impossible, which means that none of the apps are vulnerable to any they're not vulnerable, which is something we need to change. So we're going to scroll down, and we're going to click on the menu bar here that says impossible, and we're going to change it from impossible to low, and then we're going to click on submit. So after that, security level, it should say security level is currently low. So if it is, please type in chat get low Lil John, smiley face. If anybody gets that reference, then you are older than, you're probably older than 20. Okay, so get silly with it. Yeah, that's what we like to do. All right, so after you set the security level to low, we're gonna click on the command injection button over here. So these are all the different attacks you can do on DVWA. If you wanted to come back and experiment with these other vulnerabilities, you could do that. But the one we're looking for right now is command injection. So just click on that. And this is going to bring us to the vulnerable interface. So it says ping a device, enter an IP address. So all right, we can enter an IP address. Maybe we're going to put in 127.0.0.1. So this is the local host. We can submit this. Okay, and it says 4 ping packets received, 4 received, 0% packet loss. So what Linux OS command do you think is being run here? So if you don't know, that's perfectly fine. But I think if you're familiar with Linux, you should know what Linux command is being run. So the answer is ping. So this is the ping command. So whenever you see on a web app that it's running some sort of Linux OS command, then you might want to take a closer look at that interface and see if you can do some sort of OS command injection. So if once I see that something is running ping or something is running whatever output is coming out to the web app, and the output is the result of some sort of Linux command, yeah, I get that grabs my attention. So in this case, maybe we can just supply semicolon who am I hash, just like this. And this is a completely vulnerable app, so it just shows us www data. It doesn't run the ping command because we canceled out of the ping command with the semicolon over here. So that's essentially all there is. Except I think we can get a reverse shell connection by doing OS command injection. So I think we can. So in your attack box over here, you can open up a terminal, and in the terminal you can create a reverse shell listener. So netcat nlvp 443 like this, and run that. And I should make this bigger. I'll make the text bigger so that we can see what's going on. Okay. And what we can try to do is we can try to send a reverse shell command. So I think we can do the, let me just look up the netcat command. So let's see, netcat named pipe reverse shell. Okay, so this is the command right here. I'm pasting it in chat. You're going to have to replace a couple of things in the command to fit your environment. So we're going to start with the payload is going to start with the semicolon and the hashtag over here. We're going to paste in our reverse shell command over here, but we need to change a couple of things. Wait. Why didn't this? Oh, this didn't go through because we have to paste it in. Okay, so you have to go to the clipboard over here. So open up the clipboard. In the clipboard, paste in your reverse shell command, close the clipboard, and then we can start playing around with it. So in the middle here, we're going to have a command. We have to supply an IP and a port. The port number, I set it as 443. The IP address, you can actually see the IP address in, let's see, your terminal. So it says attack box IP, and it's going to have an IP address. This is your attack box IP that you need to plug in over here. Okay? So in my case, it's 10.10.206.171. That's not a 7. Okay. And then we can, I'm just going to copy this before I submit it just in case something goes wrong. Submit this. So you'll see here that the application has hung, and that's a good sign. So if we if we minimize the web browser, and then we go over to our terminal, we see that we've received a reverse shell connection. So the reverse shell connection, who am I? www data, and echo, we got reverse shell connection. Okay. Simon Dante says, nice, it worked. Also, I think the Rev Shell generator website is down. I actually don't use the Rev Shell generator website. I only use Pentest Monkey, but not that I'm saying that that the reverse shell generator website is bad. It's just I'm not in the habit of using it. I'm sure it is pretty. I'm sure it's pretty darn awesome. Okay, So yeah, that was us getting OS command injection on several different apps, and that's it for today's lesson. Before we finish out, let's do a review of what we learned today. So OS command injection, it's a web app vulnerability where arbitrary OS commands can be performed on a web server through a web interface. OS command injection can often lead to complete compromise of the web server, and if so, the server can be used as a foothold to attack other machines in the network. So we just illustrated how we could get a reverse shell into the web server by using OS command injection, and if we were able to find some way to elevate our privileges, that means that we would have completely compromised the web server. So what's next? In the next HackerFrogs After School Web App Hacking Workshop, we'll learn about the SQL database language, which most apps use for user account credentials. So we're just going to do a SQL language crash course in the next workshop, and it's actually it's important to know a few different SQL commands in order to do SQL injection, which is something that is really big in the web app hacking space. All right, so that's the end of today's class. Thank you very much to everybody who came by today to participate in the HackerFrogs After School Web App Hacking session. All right, so we're going to start the last portion of today's live stream. And in the last portion, we're just going to be doing some hacking against random CTF challenges. Today's CTF challenge is the VulNyx website basic challenge, which is number 54 on that website. If you want to take a look at yourself, you can do so at this URL. But if you want to be nice, you can close out your attacker machine, go over here, show the split view, terminate the machine, confirm, target machine information, terminate machine, just to be nice to try hack me and not run up their AWS server costs any more than they have to be. Okay, so I'm just going to take a little sip of water. I'm going to turn the music back on, and we can get on with our free hacking. All right, everybody. I think I'm going to take a little bathroom break. It's going to be 1 or 2 minutes. But in the meantime, let's watch another bird video. That's a lot of peanuts. I'll be back in a minute or two, but just got to use the washroom. Be right back. Okay, everybody, we're back, and we just finished watching one bird bullying another bird. Even birds can be bullies. Who knew? All right, so let's get out of here, and let's get started with our web app. Well, we're not doing web app hacking, so we're working on the basic machine over at VulNyx.com. And we found through our scans over here that we are working against let's do a quick nmap scan of the box one more time. So the box is over. So the machine that we're testing against is at IP address 10.0.2.49, so we need to keep that in mind when we're running our scans. So when we run nmap on it to see what we're dealing with, it has to be the correct IP address. Who knew? Okay, so we've got 3 ports that we're dealing with. We're dealing with port 22, which is the SSH service, port 80, which is the HTTP service, and port 631, which is the IPP service. More specifically, this is the CUPS service, which is a printer service on Linux, or Linux and Unix. So we were starting to investigate the printer service when we had to take a break to do our HackerFrogs class. But what we're going to do now is we're going to do some testing against the HTTP webpage on port 80. So let's do that in another tab. Let's do that in this tab. Okay, so the first thing we were going to run is the Nikto vulnerability scanner. The Nikto vulnerability scanner is an old piece of software, but it can sometimes get some low-hanging fruit vulnerabilities on these CTF challenges, so I like to run it first. So the syntax is very simple. It's just Nikto and then -h and then the IP address. So if there were any sort of common vulnerabilities available on the system, then the Nikto vulnerability scanner would be able to find them. But in this case, it doesn't seem like this is the case. So that's fine. The next thing I like to run on web servers is, let me move into the nmap, into the temp directory. I like to run the derb web brute forcing tool. And derb is actually not the best tool for doing web app directory busting, but it does have a very simple syntax. So this is why I like to run it, run Nikto and derb when I do my scans on web app hosts. So we're able to find index.html and server status. Not super helpful, but the next tool that we're going to use is a little bit more powerful, and this is the GoBuster tool. So GoBuster is a go-to tool for web app enumeration. When you do web directory busting with the GoBuster tool, you usually want to provide a powerful word list, and the standard word list we use for CTF exercises like this is the directory list 2.3 medium.txt. So this one has a lot of common directory names. So we can use this in conjunction with a lot of different extensions. So we supply GoBuster in directory busting mode. We supply -x with all of the file extensions that we want to check for. So we can check for a lot of common file extensions like XML, TXT, HTTP, HTML rather, PHP, zip, JavaScript, back, JSON. But keep in mind that each one of these file extensions is going to increase the duration of the scan by about 100%. So we've got 1, 2, 3, 4, 5, 6, 7, 8 So this is going to be 800% slower than if we just ran this by itself. But it is worth it if we're able to determine if some sort of files are on the system. So let's run this. So we get index.html that is available, and let's do some manual enumeration of the web port. So over here, we're going to go to 10.0.249. So all that's here is an Apache default web page. So this indicates that there might not be anything to investigate because there's no real website here. So sometimes there are clues on these default pages, but in a realistic scenario, there's not going to be anything that we can determine from looking at these default pages. So we can scroll all the way down to see if there's anything super relevant here. I don't think there is. Okay. So we're going to leave this scan going over here. The GoBuster scan is going to continue, and we're going to keep on investigating the web port. So, sorry, not the web port, the printer port. So we've got a printer port running on port 631. And let's go over to that page. Okay, so this is the printer page over here. So we found some printers. I think we found Dimitri's printer, right. So we found, so on the printer page over here, we were able to find a small website that deals with this, with printer administration, I guess. I've never seen anything like this before. This is my first time pen testing against printer services, so this is all new. But I see here that this Dimitri's printer exists, and because there's a name over here, then we can potentially do some brute forcing to see if Dimitri has a weak SSH password, and we can try to break into Dimitri's SSH account. So let's go over to our terminal here. I'm going to make a new terminal. Going to make this nice and big. The Vicious Gamius has just subscribed on YouTube. Thank you very much. The Thievius Gamius. Thank you very much for subscribing on YouTube. Let's do a Hack the Planet because we haven't done a Hack the Planet in a while.
Hack the planet! Hack the planet! Shut up and get it!
Okay. Alright, so let's do our user brute forcing. So Dimitri, is that how you spell it? Dimitri. Dimitri. Okay, so we're going to be doing some brute forcing on SSH against this Dimitri user. So we found Dimitri's printer, so Dimitri's probably in the user list for the system, and that's why we're going to try to brute force the password over here. So this is kind of a long shot, and brute forcing SSH is not the first thing you do. Well, I guess it's the first thing I do because because I want to run this in the background. But the reason why we usually save brute forcing against SSH as a last resort is because there are many, oftentimes in a realistic scenario, there's going to be some sort of security system for SSH that's going to see that you're trying to brute force into the system and then ban your IP address. But I don't think it exists in this challenge. So we're going to brute force, and we're going to see if brute forcing works, because sometimes it does. Okay, so this is done. This is done. This is done. What I'm going to do is I'm going to run another GoBuster command, but the GoBuster command that I'm going to run this time is going to run against the printer service. So the printer service exists at 631. So I'm going to try to brute force some endpoints with all these different extensions here. So this is probably going to go super slow, but I'm not in a big hurry. So if it takes a few minutes, that's fine. So we found a lot of different stuff, well, a lot of different endpoints here already. So we're going to investigate this after it's all done. We're getting a lot of positive results. Okay. So Dimitri's printer is here, so we can click into it. So it says Dimitri's printer, idle accepting jobs shared. All right. Defaults, socket. So this is home at this IP at this port 631. So show completed jobs, show all jobs. Nope, nope. So we could modify printer, delete printer, show default options, maintenance, pause, move all jobs, cancel all jobs. So let's see if we can do some show default options. So let's see. We've got our paper size and our resolution. I haven't dealt with printers on a serious basis in a long time. I very rarely interact with printers, but there are some people who interact with printers every day. So cups, banners, policies, retry job, set default options. Alright, so maybe Dimitri's printer, not so much we can investigate here. Modify printer, can we upgrade required, you must access this page. What? What is this? Admin, okay. I guess we can go to the page. Hold on. We can accept risk and continue. Okay, so administration, so this is the admin page here. So the admin page is not secured. We don't need to supply a password to access the admin page here. Add class, manage classes. No classes. Find new printers, manage printers. So we've been here before. This is where we found Dimitri's printer. So what else is here? So we've got printers, jobs, help. Classes. Add class, manage jobs, edit configuration file. Home. Cups for users, cups for developers. Filter and backend programming, API. This could be interesting. Okay, so we've got so file permissions. For security reasons, cups will only run filters and backends that are owned by root. Temporary files. Copy generation exit codes. I will admit I'm a bit lost because I've never really dealt with printer hacking before. But if any of the viewers have any suggestions, please let us know, because I'm basically just going to look around and see if there's some sort of vulnerable endpoint that I can find. Okay, so yeah, there's a lot of stuff here, but I'm not too sure where to start. Let's go back. So backend manual, developer forum. Well, the forum is going to go, yeah, okay. API filter, cups programming manual. using network printers firewalls, adding printers and classes. Okay. So maybe what we should do is let's check on our brute force. So, oh, we found a brute force. We found Dimitri's password through brute force. Okay. All right. So we don't need to. I guess we're done with printer stuff. We don't need to hack the printer. We've got Dimitri's SSH password. Great. All right. So let's. You know what? I'm gonna record this. Nice. My money is on SSRF somewhere. Just a guess. SSRF is a little bit. I think SSRF is a little too advanced for these low-level machines. So everybody, I'm gonna take a couple of minutes, and I'm going to record everything we found on this system so far. So just let me write some notes. So this is the basic machine. Okay, so I've got my notepad. I'm going to make this nice and big so that we can read all the stuff that I'm writing out. Okay, so I need to make it bigger. Okay, there are ports 22, 80, and 631 on the server. Okay, second of all, when we investigate the printer service on port 631, we are able to access the admin panel without a password. We are able to determine a username by the printer names on the system. The username is Dimitri. We are able to brute force Dimitri's SSH login with the Hydra tool. And it's Dimitri me. That is the password. Okay, so that's everything we have so far. So let's log in as Dimitri. So it's SSH Dimitri at 10.0249. Oops. 249. We do want to connect, and the password is me, and we're in. All right, so this is the second time we've gotten in with the system in today's stream. So let's put on the voice changer.
This is my scary hacker voice. I use this voice when I do scary hacker things. And when we enter a remote server, we like to say, "We're in."
And then we change back to our original voice. So some people might think that this is my voice changer voice, and the other voice is my regular voice. That's not the case. All right, so what is on the system? We've got user.txt, and let's find out if Dimitri has sudo access. So sudo does not exist on this box. So Ordino and Contrada. Nortox has just subscribed on YouTube. Thank you very much for the subscription on YouTube, Nortox. Was it the voice? I'll try to speak with a deep voice more often from now on. Okay, so orden no encontrada, this is Spanish, it means command not found. So the next thing we can do is we can take a look at the opt directory to see if there's any unusual software in here. There is not. We can also take a look at the web directory. The web directory only has index.html. So what else is in Dimitri's home directory here? So it doesn't look like there's anything that can help us. So let's see if there's any... Okay, so let's try to see if there's anything in the etc. directory which is writable. Oh, there's nothing in the etc. directory which is writable. Okay, so that's fine. What other checks can we try? We can try to look for SUID binaries. So I need to look this up every time. Yeah. Find / U equals S. Oh, perms. Perm. Was it U equals S? I think. I think this is how you find it. Okay, yeah, that's it. Okay, so there's env, mount. I think these are all normal. I don't think there's anything super special about these SUID binaries. Of course, I could be wrong, so I'm going to feed this into ChatGPT, and I'm going to ask ChatGPT if any of these SUIDs are unusual. Are any of these SUID binaries unusual from a CTF perspective? The ENV one, yeah, I think ENV might be. Okay, so let's see. Unusual in the CTF. SUID ANV is not common and could be useful for privilege escalation. It can be used to execute commands as different users if misconfigured. If NENV is SUID, you could potentially use it to run a shell with elevated privileges, like so. Okay. Let me look this up in what was it? GTFO bins. So GTFO bins is the go-to place for looking up ways to do privilege escalation with different Linux commands. And this one is right. It's right here. Yeah, good eye, Cybernerd Dante, for pointing out the ENV SUID. So let's see ENV with SUID. So if the binary has the SUID bit set, it does not drop elevated privileges and may be abused to access the file system, escalate, or maintain privilege access. As a SUID backdoor, it is used to run sh-p, omit the p on argument on systems like Debian that allow the default sh shell to run with SUID privileges. Okay, so .env bin. Oh, is that all? Is that all we need to do? Okay, so env. Ooh, did my system freeze up? Okay, so let's see, user bin env, I think, and then bin sh. Who am I? Okay, that didn't work. What am I doing wrong? The P? Okay, we could try the P. Dash. Is it dash P here? Oh, it was the P. Yeah, good eye. Good eye. Okay, so we're root now. And because we're root, we can run this redeem.
What are you?
I'm system root.
So if you recognize that movie, you're also probably an old person because the Batman movie there is from the year in 1989. All right, so who am I? I am root. So we've effectively rooted the system. Let's move into the root directory, and we see here root.txt. So we're not going to read the root.txt file because we want to be respectful to the people at VulNyx.com who don't want people who are doing live streaming or writing up guides to read these flag files. So what we're going to do is we're going to cat root.txt and redirect it into iReadRoot.txt. We see here that these two files exist and they're the same size. And if we do our md5 sum on root.txt and iReadRoot.txt, then we see that the md5 sum shows that they have the same file hash. So that means that we read the root.txt file. All right, we're done. Thank you very much for everybody for your support and your insight. Thank you very much to CyberNerd Dante with a couple of sharp observations. Okay, so we still have some time. We still have about half an hour that we can kill. Maybe we can start on the next box. So the next box on the list is... So we've got the basic machine. We did the first machine. We've got Mux, Infected, and Agent for next week. So maybe we should do... Oh, there's a Windows machine. Maybe we should try the Windows machine. Okay. I'm going to download this off stream. Sorry, not off stream. I'm going to download this off screen rather. So why don't you guys watch a bird video while I so this classic video. I'm going to download the machine right now. VulNyx. So Renee Dante says, "Hey man, thanks for the class and streaming. I got to run, but I'll tune in next time for sure." Thank you very much for stopping by, CyberNerd Dante. It was fun interacting via chat. You had a lot of smart things to say, I think. And if you learned something, then I'm glad to teach, and I'm glad to learn from you as well. Let's send you out with a Hack the Planet, because this is what we do.
Hack the planet! Hack the planet! Shut up and get out!
Hope to see you next time. Alright, so I'm just going to download the experience box. It is number 70. I'm going to download that thing. And then I need to put it on my network. All right. So I haven't hacked a Windows machine in a long time. I hope I remember how. It's definitely different than hacking Linux stuff. But let's see. So I'm just in the middle of installing this on my network. Let's see if some more birds come back. Where are we? Here we are. Okay. Come back, birds! So this is the bird with the broken foot. And then let's install the system. Huh, where did the machine go? That's weird. Then the machine isn't showing up in my machine list on VirtualBox. That's weird. Let me try installing it again on VirtualBox. Import appliance. It is I wonder why this isn't working. Oh, no. Okay. I've got it now. Huh, this is a Windows XP machine. Weird. Alright. It's probably going to be some super common vulnerability that this is vulnerable to. I need to put this on my network. And then I need to shut down the USBs. And then I need to start up the machine. Okay. I'm starting up the machine now. This is Windows XP. Huh. Oh, we know, well, I guess we know that Bill is the username because Bill is here. Alright, so that's some information that we know. So the interesting thing about the Windows machine is that... Okay, so I'm just going to do some housekeeping. I'm going to shut down the basic machine because Windows machines take up a lot of RAM, and I don't want any unnecessary eating up of my resources. So the first thing we need to do is we need to figure out where the machine is on our network. So we're going to run the nmap command with SN, I think, is the tag. So this is going to run a ping sweep command if we supply the correct one. So I think this is the correct command for ping sweep. No? Is it S? Let me ask ChatGPT what the ping sweep command is, because I don't remember it offhand. What is the nmap ping sweep syntax? Okay, so it's SN. Oh, okay. It's not capital. So just this. So this is going to let us know what machines exist on our network. So we've got 1, we've got 22, which is our attacking machine, and we've got 51, which is the new target. So we're going to run another nmap scan, and we're going to run it with all of our favorite arguments over here on IP 0.2.51. So a lot of Windows machines are not going to respond to ping packets, but this one does. Okay. So we discover these ports over here, 139, 445, 135. When we're going into this exercise, we know from the login screen over here that there is a user named Bill, so we can keep that in mind. We're running against 3 ports, 139, 445, and 135, and these ports are associated with the SMB service. So SMB is server managed block. It's the Windows version of file sharing across networks. And let's take a look at what Nmap came back with. So we've got Microsoft Windows RPC, NetBIOS scan on and port 445, which is Microsoft Data Store. So this is the SMB that we were talking about. So we couldn't establish an SMB v2 connection. Okay. We've got Windows XP. So Windows XP is a very, very old version of Windows. It's from... Is it from the year 2000? Yeah, I think it's from the year 2000 or so. So that was about 24 years ago. Okay, I haven't done any security testing against Windows machines in years. So I'm gonna have to remember how to do this again. First of all, let's use a super old tool. It's called enum for Linux. And enum for Linux is a very old tool for scanning against SMB configurations. More specifically, it's for Samba, but I think it works for SMB as well. So this is going to be 51. Let's see if it finds anything. Let's redirect this into enum for Linux. .txt. And we'll run that as a... We can just run that and see if anything comes out of it. We should wait for a little while to see results come back. Okay, so next we can do... What else can we do? Let me ask ChatGPT. It's been a while. Actually, no. Let's not ask ChatGPT yet. Let's go to HackerFrogs. So HackerFrogs, we can ask it about port 139, pentesting SMB, and we can take the advice over here. Okay, so basic info. Why are we talking about finger here? I need to reload this. Okay. Alright, so we've got port 445. This is SMB. And server message block, yeah. Client server model. IPC share. Enum for Linux, yeah. NTLM, server enumeration, scan and network searching for hosts, SMB server version. Okay, brute force, SMB environment information, obtain information. Okay, so we've got crack map exec. This info should already be gathered from enum for Linux and enum for Linux ng. Oh, I didn't know that there was an ng. So there's also impacket that we can use to look up local usernames. But we know the local username because we cheated and on the login screen, and the user is named Bill. We can enumerate local users. Okay, so let's take a look at the enum for Linux file and see if anything was returned. Enum. Okay, so no printers, RID cycling not possible. Okay, so didn't get any information. Attempting to map shares, couldn't find any shares. Okay, so I get the feeling that this is an old box. It's running Windows XP, so it might be vulnerable to some sort of well-known exploit. So I think shared folders. Download files, domain, read registry, post exploitation. Authenticate using crapmech exec. Impacket, brute force, SMB relay attack, SMB trap. SMB trap using man in the middle MF. What does MF stand for? Hack tricks, automatic commands. Okay, I think there were some so we can scan with Nmap to see if it's vulnerable to some well-known exploits such as Eternal Blue or something else. Let me ask ChatGPT what the scripts are. What are Nmap scripts that can be run against Windows machines that check for common SMB exploits such as Eternal Blue? Nmap has several. Okay, so this one that's scan Windows machines, check for SMB vulnerabilities, including the infamous Eternal Blue exploit. Here are some key Nmap scripts for this purpose. Vuln MS17-010. Okay, so this is Eternal Blue. And this is the Conflicker worm. And this is this vulnerability. Okay. And these other two vulnerabilities. Run wildcard to run all SMB vulnerability scripts. Thank you very much. This is very handy. So I think I'm going to run this to see if it's vulnerable to any of these SMB vulnerabilities. So back over here, scroll all the way down, and let's run this Nmap script against 10.0.2.51. So we're going to check for Eternal Blue and all those other funny SMB vulnerabilities. Oh look, it's vulnerable. Okay, so this is vulnerable. Microsoft Windows System vulnerable to remote code execution. State likely vulnerable. So this is likely vulnerable, but this is definitely, well, it says more vulnerable. So this is, what is it? What is this? Okay, so I'm going to research this vulnerability. I don't know if I've actually run this exploit before, but I can check. Okay, so let's check up with ChatGPT. What is this SMB vulnerability? Then give it the CVE number. Okay, so this is an SMB vulnerability that affects Microsoft Windows SMB version 2. It's a remote code execution vulnerability, SMB version 2, implemented on Microsoft Windows. Vulnerability is triggered by a malformed packet, right? Attack vector. Okay. So there might be some. Let's search exploit this. Okay, no results. So search exploit doesn't work. Let's try looking in the Metasploit. Let's try looking in Metasploit rather. So we're going to clear, and then we're going to start up our Metasploit framework console. And then we're going to try searching for that term to see if there's some sort of Metasploit module that takes advantage. Okay, so search this thing. Okay, so I think, so MS09-50, let's double check that that's the correct one. 09-50, okay, I think this is the correct vulnerability here. So this one is, so let's use this exploit. Use 0. And then let's show info. Okay, so the module exploits an out-of-bounds function table reference in SMB. Okay, so Windows Vista, Windows 7, and Windows 2008 server prior to R2. Alright, so what we need to provide is we need to provide an IP address. And okay. So the only thing we need to do to run this exploit is to provide an IP address. So we're going to do set our hosts and then 10.02.50 51. Okay. So show info, show settings. Was it show settings? Show. I guess show info. Okay, so we've got this, we need this, we have this set, this is the ARP port, and wait. Okay, so I think from here we can just run the exploit. So let's try run exploit. Huh, exploit failed and reachable, the connection was refused by the remote host. Exploit completed, but no session was created. That's unusual. Anyways, let's try the attack on port 139. Set R port 139, and then let's run it again. Okay, so this, we're able to communicate with the port at least. So I guess we need to wait for a while to get this going. Waiting up to 180 seconds for the exploit to trigger. So let's do some waiting. If anybody has any questions about anything we've done today, you can go ahead and type in the chat. I'll try to answer your questions as soon as I can. In the meantime, let's do a fun video redeem. I haven't done this one in a while. It's go to hack.
Mr. Hat, may I please be excused from class?
Well, Carl,
Yes.
you hear me? You go to
Hack.
You go to
Hack.
You
Have a great day.
I hope everybody's having a great day. It is Friday night over where I am. It might not be Friday night where you are, but hope everybody's having a great time. Alright, so let's see. If this fails, is there anything else? Is there anything else that we could potentially do? We could look for another exploit. There might be one that we can find online, but I guess we'll just wait. We'll wait for this, and maybe we can look for something else in the meantime. So this is the CVE that we're looking for. Let's go over here. Exploit, let's put in GitHub. Okay, so this is a GitHub version that we can potentially look at. So it's a one-liner to generate, create a payload for Windows, MSFNM, blah, blah, blah. Okay, let's take a look at it. So this is a Python file. So let's see. This is a one-liner. One-liner start interpreter. Does this just... Is this just using Metasploit? Okay, well, this is less impressive than I thought it would be. Let's go back to Metasploit. So Metasploit is still running. I don't know if we're going to... 180 seconds, that's 3 minutes. 3 minutes is forever. Okay. So let's... we can clear this. We can also clear this. We can clear this. This is waiting to run. Let's see. So this might not go through. This might not go through. But let's look for some other stuff in the meantime. Exploit completed, but no session was created. Yeah, it didn't work. Okay. Let's look around for something else. Okay, so this is another one. It's a Python script using an updated version of the public exploit for this. Okay. Let's try. Let's take a look. Okay, so this is a Python script. An updated version of the public exploit for this CVE. The original code relied on the SMB Connect module, which has been replaced in this version to make the script more versatile and compatible. Alright. Clone the repository. Run the exploit script with the target IP. Okay. Okay, let's clone the repository. So go over here, copy the repository, then go over to another tab, git clone, this thing. Alright, so let's take a look at this Python code. So what we're going to do is we're... Hack Smarter, hello! What are we hacking tonight? We're hacking a very old Windows machine. I think it's vulnerable to some public exploit. And it's got a bunch of shell code in here. It's using the sys and subprocess and the socket libraries. I'm going to run this by ChatGPT real quick to make sure that nothing weird is happening in here. But Hack Smarter, hello and welcome. If anybody doesn't know, Hack Smarter also has a Twitch channel, and Hack Smarter is a very well-informed hacker. We're gonna give him a shout out. Shout out Hack Smarter. There we go. And just for fun, let's do a all the things redeem.
This one's dedicated to all the hackers. Yo.
All right, so let's double check that this Python script isn't going to do anything malicious to our system. Is there any risk to our local host in the following script? Paste. The script attempts to exploit a vulnerability in a remote target. specifically over port 445. Okay. Shellcode, connection handling, subprocess execution. Best practices to minimize risks. Okay. While the script targets a remote host, a misconfiguration or typo could cause accidental execution on localhost. Okay. All right. All right. So let's try running the script then. Okay, let me ask another question. So my other question is, what is required to run this script? Okay, so we need a Python environment, Python 3, right? Socket module, subprocess, this is standard. The script includes comments suggesting the use of MSS Venom to generate shellcode. Network requirements, target IP address, port 445 access. Okay, so we just need to do Python script, right? Okay. Well, let's give it a try. This is going to be Python ms something 10.0251. Connection refused. Well, connection refused means connection refused. Alright. Anything else we can do with this? Are there options in the script to run against ports? Actually, you know what? We could probably just look at the script and see where 445 is in the script and change it to something else. Let's see. No, MS. Okay, so we're looking at port. Let's try port 139 instead. Nope. Wait, what was the other SMB related port again? SMB is associated with port 445 and what other ports? Was it 139 or 135? $139, yeah, right, for SMB over NetBIOS. So I guess this script doesn't work. Ooh, how do we do this? So hold on. Let's get out of here. So we were scanning. What? The port is closed. The port is closed. Why is the port closed? It wasn't closed before? Okay. Let's take a look at all the ports. Let's see. T1. So only 135 and 139. For some reason the SMB port isn't open anymore. Does that mean we need to reset the box? Okay, I think I need to reset the box. So this box, this Windows box over here, it seems to have gone funny. So I'm going to shut down the system and I'm going to restart the box. So the great thing about running vulnerable machine, about pen testing CTF boxes on your own network is that you can restart the boxes as many times as you like in case something goes weird. So we're just going to wait for this to power up, and then I'm going to try my my exploit script again. So let's scan the box. Let's scan the box. Let's scan the box. Okay, now we have port 445, 139, and 135. Okay, so now we can try our exploit script again. So the exploit script is Python. We need to modify the script. Host target 139. It is not 139. It is 445. All right, done. Let's Python this thing. Okay, so cannot connect to server, login failure. So this didn't work. Let me see if port 445 has gone down. Okay, port 445 is still up. So let's try the Metasploit script. So Metasploit framework. Let me grab that CVE one more time. The CVE is this one. Okay, so we're going to search for that. And then we're going to use the exploit script over here. Show info. We need to set the R hosts. So we're going to set it. Set R hosts 10.02.51. Run the exploit. Okay. So we managed to get this going. It's going to take up to 180 seconds for the exploit to trigger. This is where we pull up our bird video again. Ah, look at the bird. Isn't it a pretty bird? This is a Stellar Jay. It's the best bird on the planet. It's eating peanuts. It is awesome. But I think I'm reusing. I'm using these bird videos too much. Anyways, if anybody has any questions about cybersecurity or anything like that, please ask in the chat while we're waiting for the exploit to trigger. Takes 180 seconds. So once again, we are doing pen testing against this super old version of Windows XP over here. And Windows XP is... how old is it at this point? Let's do Wikipedia. And let's look for Windows XP. So it is a Windows NT operating system. It was released to manufacturing in 2001. 2001, geez. What was everybody here doing in 2001? 2001, what was I doing? I don't want to think about it. Okay, but yeah, this Windows XP is nearly 24 years old. But let's take a look and see if the exploit has finished or not. Waiting up to 180 seconds for the exploit to trigger. If this doesn't work, we're gonna have to nmap for Metasploit. We're going to have to run nmap and see if it's vulnerable to any other exploits. So waiting up to 180 seconds. So everybody, I'm gonna run a Twitch ad while the exploit is waiting to trigger. It could take a little while. Please watch the ad to earn me a few pennies, and because this is mandatory on Twitch. If you're not, okay. So the exploit completed, but no session was created. Okay, so we're just gonna get out of here, and we're gonna see if what other well-known exploits we could run against this. So likely vulnerable is this one right over here. It says vulnerable to this one, but it says vulnerable to this one as well. MS-17. Okay, so let's look for this inside of Metasploit framework. Okay, and then search for this vulnerability. It's thinking. Is this Eternal Blue? This is Eternal Blue. Huh. Is this going to be vulnerable to Eternal Blue? So rank average, rank normal, rank great. Okay, so we're going to use exploit number 27. And then we're going to show our options. Okay, so set lhost. Set lhost 10.02.22. Set lport. Let's do 443. Set our hosts. Set our hosts 10.02.51. And then exploit. No session was created. Exploit aborted due to failure bad config. Are you sure you want to execute code against a nation-state implant? You may contaminate forensic evidence. Disable the defanged mode option if you have authorization to proceed. Okay. Disable the defanged mode option. Show advanced. Where's the defanged mode option? Defanged mode, where is it? Show options. Are you sure you want to execute code? Disable the defanged mode option. Where is the defanged mode option? No options. Show advanced. Okay, so here it is. Defanged mode. Defanged mode false. Set defanged mode false. Okay, let me copy this. Copy. Set defanged mode false. Okay, now run. The connection was refused by the remote host. Refused by the remote host. Did port 445 go down again? Okay, nmap this thing. Yeah, port 445 went offline again. Okay, I think, Alright, we might, well, we're not we're not really getting anywhere. Let's see if there's somebody we can raid on Twitch. So there's the InfoSec streamers, infosecstreamers.com, and there is Tiberius. Tiberius is online. Hey, Tiberius is a great content creator. He creates a lot of web application hacking content, and he is on Twitch. So I never know how to spell his name. I'm just going to copy this. But thank you very much to everybody for watching. It is Friday, so everybody TGIF. We'll be back on Monday, and we're going to be doing more hacking then. But thank you very much for everybody for hanging out and for watching. Even if you don't chat, I appreciate you. Let's redeem one last Hack the Planet before we go out.
Hack the planet! Hack the planet! Shut up again!
So everybody, when you arrive at Tiberius's chat, if you could type the following message, hip hop hack with the OS frog, I would really appreciate that. But everybody, see you next time. Have a great weekend. We'll see you on Monday, if you are here.